ஓகே, இது உங்களுக்கு புரியுதுங்களா? சாய்ஸ் ஆஃப் டெஸ்ட். பின்னாடி இருக்கிறவங்களுக்கு வந்து தெரியலன்னா நீங்க கொஞ்சம் முன்னாடி வந்துருங்க. இது உங்களுக்கு புரியுதுங்களா? இதுல ஏதாச்சும் டவுட் இருக்கா? நம்ம என்ன பண்ணுவோம் யூஸ்ஃபுல்லா? இன்புட் வேரியபிள்னு சொல்லுவோம், அவுட்கம் வேரியபிள்னு சொல்லுவோம். இந்த எபிடமியாலஜிக்கல் டேர்ம்னா எக்ஸ்போசர் அண்ட் டிசீஸ்ன்னு சொல்லுவோம், இல்லாட்டி எக்ஸ்போசர் அண்ட் அவுட்கம் சொல்லுவோம். இந்த மாதிரி எக்ஸ்போசர் வேரியபிளா இருந்தா என்ன வேரியபிள், அவுட்கம் வேரியபிள் whenever இதா இருந்ததுன்னா நம்ம வந்து என்னென்ன டைப் ஆஃப் அனாலிசிஸ் பண்ணணுங்கிறத இது சொல்லுது. சரி, ஓகே. இது வந்து என்ன டிஸ்பிளே ஆகுது, கீழே வந்து பேர்ட் இன் நேச்சர். ஸோ ஸ்டார் போட்டிருக்கிறதெல்லாம் வந்து பேர்ட் இன் நேச்சர். நீங்க கொஞ்சம் பாத்துங்க. ஏன்னா நம்ம கப்பா ஸ்டாட்டிஸ்டிக்ஸோ அல்லது மெக்னமார் பேரிட்டி டெஸ்ட் இதெல்லாம் வேணும்னா, அப்புறம் கார்லேஷன், லீனியர் ரிக்ரெஷன்னா திஸ் இன்புட் வேரியபிள் அண்ட் அவுட்புட் வேரியபிள் சுட் பி பேர்ட் இன் நேச்சர். அது வந்து ஒரு இம்பார்ட்டன்ட் ரிக்வயர்மெண்ட். இது ஓகே தானே? இதுல உங்களுக்கு ஏதாச்சும் டவுட் இருக்கா? ஓகே, ஸோ do you know what is sampling unit? Sampling unit na enna? What is sampling unit? சொல்லுங்க. தப்போ ரைட்டா உட்கார்ந்து இருக்காதீங்க, டைம் வேஸ்ட் பண்ண வேண்டாம். I want a layman's definition. ஏன்னா புக்ல எல்லாத்துலயும் கொடுத்திருப்பாங்க ஒரு layman's definition. சப்போஸ் நீங்க வந்து நான் கேட்கிறேன், so I want to know the ஒவ்வொரு வீட்லயும் வந்து டாய்லெட் ஃபெசிலிட்டி இருக்கா இல்லையான்னு தெரிஞ்சுக்கணும். அப்போ வந்து நான் எங்க போனா எனக்கு வந்து அந்த ஃபெசிலிட்டி, அந்த இன்ஃபர்மேஷன் எங்க கிடைக்கும்? சொல்லுங்க. வீட்டுக்கு தான். ஒவ்வொரு வீட்டுக்கு போனா தான் எனக்கு வந்து டாய்லெட் ஃபெசிலிட்டி இருக்கா இல்லையான்னு கிடைக்கும், இல்லையா? கரெக்டா இல்லையா? சோ அப்ப சாம்பிளிங் யூனிட் வந்து ஹவுஸ் ஹோல்டு. ஓகேயா? அடுத்து வந்து ஐ வாண்ட் டு நோ தி ஹீமோகுளோபின் லெவல். அப்போ வந்து எனக்கு வந்து சாம்பிளிங் யூனிட் வந்து என்ன, ஒருத்தரோட ஹீமோகுளோபின் லெவல் தெரிஞ்சுக்கணும்னா பர்சன். ஓகே, இப்போ வந்து பாத்தீங்கன்னா இந்த டென்டல்ல வந்து நம்ம என்ன பண்ணுவோம், இந்த சொத்தைக்கெல்லாம் வந்து ஒரு சிமெண்ட் வச்சு அடைப்போம், இல்லையா? ஒரு புது சிமெண்ட் வந்திருக்கு. அந்த சிமெண்ட் வந்து எல்லா சிமெண்டோட பெஸ்ட் சிமெண்ட். அது நீங்க ஃபுல்லா அதை அடைச்சிட்டீங்கன்னா ஒரு வருஷத்துக்கு வந்து அந்த சிமெண்ட் வந்து அப்படியே இன்டாக்டா இருக்கு, கீழே விழுகாதுன்னு சொல்றாங்க. இப்போ வந்து அந்த சிமெண்டோட எஃபிகசி, அப்போ வந்து எனக்கு வந்து சாம்பிளிங் யூனிட் வந்து என்னவா இருக்கும்? கொஞ்சம் சவுண்ட் நாங்க அப்படியே சொல்லுங்க, சொல்லுங்க, கொஞ்சம் லவுடரா பேசுங்க. சிமெண்ட்ங்கிறது வந்து என்னோட இன்டர்வென்ஷனல் ப்ராடக்ட். கேரிஸ், ஓகே, அதாவது வந்து கேரிஸ்னா டு பி ப்ரீசைஸ், சிங்கிள் கேரியா இல்ல பல்லா இல்ல மனுஷனா, எது வந்து சாம்பிளிங் யூனிட்? சிங்கிள் கேரி. ஓகே, ஏன்னா ஒருத்தருக்கு 4 சொத்தை இருக்கு. அப்ப 4 சொத்தைக்கு நான் வந்து அந்த சிமெண்ட் வைக்கலாம். சோ என்னோட சாம்பிளிங் யூனிட் வந்து a single carry is my sampling unit. சோ இதுல இருந்து உங்களுக்கு என்ன தெரியுது? What is sampling unit? It's a basic unit or item upon which we are going to investigate or measure the measurement. அதான் sampling unit. It is இந்த sampling unit தான் உங்களுக்கு வந்து ரொம்ப ரொம்ப யூஸ்ஃபுல் ஆகும். உங்களோட சாம்பிள் சைஸ் என்னன்னு சொல்றேன் பாத்தீங்களா? That is nothing but your sampling unit. அந்த எண்ங்கிறது வந்து அதுதான். இப்போ வந்து கேரிஸ் பொறுத்த வரைக்கும் எண் வந்து 30னா அது உங்களுக்கு 3 பேர்த்துல கிடைக்கலாம், 30 பேர்த்துலயும் கூட கிடைக்கலாம். So I need only 30 carries, not 30 persons. ஓகே, இப்போ வந்து நான் ஹவுஸ் ஹோல்டு டாய்லெட் ஐட்டம்னா I need 30 households. அப்பதான் வந்து எனக்கு அது கிடைக்கும். So sampling unit is the basic unit upon which we are going to collect the information. Okay, right. Null and alternate hypothesis. Okay. What is sampling distribution? Sampling distribution என்ன? ஓகே, ஆர்டினரி டிஸ்ட்ரிபியூஷன் என்ன? நார்மல் டிஸ்ட்ரிபியூஷன் என்ன? பைனாமியல், பாய்சான் கேள்விப்பட்டிருக்கீங்களா? கேள்விப்பட்டிருக்கீங்களா இல்லையா? நார்மல் பெல்ஸ் எப்படின்னு இவங்க சொன்னாங்க, கிருத்தியா மேம், இல்லையா? பைனாமியல் கேள்விப்பட்டிருக்கீங்களா? பைனரி டேட்டா ஃபாலோ பண்றது பைனாமியல். ஓகே, சோ என்ன ஆகும்னா நம்ம ஒரு பாப்புலேஷன்ல இருந்து சாம்பிள் எடுக்கிறோம். ஓகே, சோ இப்போ வந்து இதுதான் வந்து என்னோட பாப்புலேஷன் வச்சுக்கோங்க. சோ மை பாப்புலேஷன் இஸ் the PG scholars and persons attending the SPSS. This is my population. I want to take sample size of 10. 10 பேர் நான் சாம்பிள் எடுக்கணுங்கிறேன். எத்தனை சாம்பிள் 10 எத்தனை சாம்பிள் எடுக்க முடியும்? எவ்வளவு சாம்பிள் 10 எடுக்க முடியும்? 6 செட் எடுக்கலாங்கிறீங்க. சரி, நான் ஒண்ணு பண்ணிடுறேன். இந்த ஃபர்ஸ்ட் 10 பேர் எடுக்கிறேன், திருப்பி அந்த 10 பேர்த்த உட்கார வச்சிடுறேன். அப்படி பார்த்தா எவ்வளவு எடுக்க முடியும்? நிறைய எடுக்க முடியும் இல்லையா? ஓகே, அந்த 10 நான் நிறைய பேர்த்த எடுக்க முடியும். ஸோ இந்த 10 பேர்த்தோட வெயிட். ஓகே, ஸோ ஐ கேன் நான் வந்து ஒரு 100 செட்டும் கூட எடுக்கலாம் இல்லையா? ஸோ இப்போ வந்து அந்த 10 பேர்த்தோட வெயிட், ஆவரேஜ் வெயிட் பண்றேன். ஸோ ஆவரேஜ் வெயிட் ஆஃப் ஃபர்ஸ்ட் 10, ஆவரேஜ் வெயிட் ஆஃப் செகண்ட் 10, ஆவரேஜ் வெயிட் ஆஃப் தேர்ட் 10, இந்த மாதிரி போயிட்டே இருக்கு. இந்த ஆவரேஜ் மீன்ஸ் எல்லாம் இருக்கும்ல, இது வந்து ஒரு ரேண்டம் வேரியபிளா கன்சிடர் பண்ணலாமா? ஏன்னா எல்லாத்தோட வெயிட்டும் ஒரே மாதிரி வராது இல்லையா? ஒருத்தருக்கு வந்து 55 ஒரு சாம்பிள் வரலாம், இன்னொரு 56 வரலாம், 57 வரலாம். ஸோ இந்த 56, 57, 54 இதெல்லாம் வந்து ஒரு ரேண்டம் வேரியபிளா இருக்கும். அப்ப இது ஒரு ரேண்டம் வேரியபிள்னா இதுக்கு ஒரு டிஸ்ட்ரிபியூஷன் இருக்கும்ல. This mean is behaves like a random variable. The distribution of mean is called sampling distribution. ஓகேங்களா? அந்த சாம்பிளிங் டிஸ்ட்ரிபியூஷன் தான் நம்ம டெஸ்டிங் ஆஃப் ஹைபோதீசிஸ்ல யூஸ் பண்ணுவோம். நம்ம கிரிட்டிக்கல் வேல்யூன்னு சொல்லும் போதுல அது. ஸோ ஈச் அண்ட் எவ்வரி ஸ்டாட்டிஸ்டிக்னா என்ன? டிஸ்கிரிப்டிவ் ஸ்டாட்டிஸ்டிக்ஸ்னு படிச்சிருக்கு இல்லைங்களா? வாட் ஆர் ஆல் த டிஸ்கிரிப்டிவ் ஸ்டாட்டிஸ்டிக்ஸ்? மீன், மீடியன், மோட், ஸ்டாண்டர்ட் டிவியேஷன். ஸோ ஒவ்வொரு டிஸ்கிரிப்டிவ் ஸ்டாட்டிஸ்டிக், அதாவது மீன்னா இட் ஹாஸ் இட்ஸ் ஓன் சாம்பிளிங் டிஸ்ட்ரிபியூஷன். ப்ரொபோர்ஷன்னா பி. ப்ரொபோர்ஷன்ங்கிறது வந்து ஒரு இதுதானே. இப்போ பர்சன்டேஜ் ஆஃப் மேல், பர்சன்டேஜ் ஆஃப் ஃபீமேல் இருக்குதா, இது அந்த பி, இட் ஹாஸ் இட்ஸ் ஓன் டிஸ்ட்ரிபியூஷன், சாம்பிளிங் டிஸ்ட்ரிபியூஷன். ஸோ ஒவ்வொரு டெஸ்ட் ஸ்டாட்டிஸ்டிக்கும் ஒவ்வொரு சாம்பிளிங் டிஸ்ட்ரிபியூஷனா இருக்கு. இப்போ யூஸ்வலா பாத்தீங்கன்னா நம்ம வந்து டி டெஸ்ட்னு சொல்லுவோம். அந்த டி டெஸ்டோட சாம்பிளிங் டிஸ்ட்ரிபியூஷன் வந்து என்ன? டி டிஸ்ட்ரிபியூஷன். ஓகேங்களா? இசட் டெஸ்ட்னு சொல்லுவோம். இசட் டெஸ்டோட சாம்பிளிங் டிஸ்ட்ரிபியூஷன் என்ன? இசட் டிஸ்ட்ரிபியூஷன். கம்பாரிசன் ஆஃப் வேரியன்ஸ்க்கு வந்து என்ன சொல்லுவோம்? எஃப் டெஸ்ட்னு சொல்லுவோம். அந்த எஃப் டெஸ்டோட சாம்பிளிங் டிஸ்ட்ரிபியூஷன் வந்து என்ன? எஃப் டிஸ்ட்ரிபியூஷன். அடுத்து கை ஸ்கொயர் டெஸ்ட்னு சொல்லுவோம் இல்லைங்களா? கை ஸ்கொயர் டெஸ்டோட சாம்பிளிங் டிஸ்ட்ரிபியூஷன் வந்து என்ன? கை ஸ்கொயர் டிஸ்ட்ரிபியூஷன். ஓகே, சோ இதுதான் சாம்பிளிங் டிஸ்ட்ரிபியூஷன். இது ஞாபகம் வச்சுக்கோங்க. அடுத்து சிக்னிஃபிகன்ஸ் லெவல் தெரியும், ஆல்பா. டைப் 1 அண்ட் டைப் 2 எரர் தெரியுமா தெரியாதா? ஓகே, சிக்னிஃபிகன்ஸ் லெவல் ஆல்பான்னு சொல்றோம்ல, அதுதான் வந்து டைப் 1 எரர்னு சொல்லுவோம். டைப் 1 எரர்னா, ஐயோ அதை எடுக்க நான் ரொம்ப லேட் ஆக மாட்டேன் இருக்கேங்க மேடம். சோ நீங்க படிச்சுக்கோங்க. கான்ஃபிடன்ஸ் லெவல் அண்ட் பவர் இதெல்லாம் வந்து நீங்க படிச்சுக்கோங்க. பி வேல்யூ அண்ட் இன்டர்பிரேஷன். பி வேல்யூ அண்ட் இன்டர்பிரேஷன் வந்து ஒரே டெசிஷன் தான். இஃப் லெஸ் தேன் 0.05 ரிஜெக்ட் H0, மோர் தேன் 0.05 அக்செப்ட் H0. ஓகே, ரைட். சோ இது உங்களுக்கு எல்லாம் தெரியும். 5 ஸ்டெப்ஸ் மேனுவலா பண்றீங்களா இல்லையா? அது இதுதான் ஃபாலோ பண்றீங்க. ஓகே, இப்போ வந்து நீங்க வந்து ஒன்லி ஃபர்ஸ்ட் ஸ்பெசிஃபை நல் அண்ட் ஹைபோதீசிஸ், டிராயிங் கன்க்ளூஷன் பேஸ்ட் ஆன் தி பி வேல்யூ. இதுதான் நீங்க வந்து நம்ம SPSSல நம்ம பண்ண போறோம். ஓகே, சோ டெஸ்ட் ஃபார் வேரியன்ஸ். சோ எப்ப டெஸ்ட் ஃபார் வேரியன்ஸ் யூஸ் பண்ணுவீங்க? 2 கண்டிஷன் இருக்கு. ஒன்னு டி டெஸ்ட் அல்லது அனோவா பண்றப்ப அது ஒரு பேசிக் அசம்ப்ஷன் சாட்டிஸ்ஃபை பண்ணா கம்பேரிசன் ஆஃப் வேரியன்ஸ் இது பண்ணுவோம். நேத்து ஒரு எக்ஸாம்பிள் சொன்னேன் டெஸ்ட் ஃபார் வேரியன்ஸ்க்கு. என்ன எக்ஸாம்பிள்? சொல்லுங்க, டைம் வேஸ்ட் ஆகுது. இல்ல எஃப் டெஸ்டுக்கு வந்து நான் ஒரு எக்ஸாம்பிள் சொன்னேன், சித்தா ரெஜிமெண்ட் வச்சு. 2 மெடிசன் கொடுக்குறீங்க ஹைப்பர்டென்சிவ்க்கு இல்லையா? எந்த மெடிசன் வந்து மோர் கன்சிஸ்டன்டா, இன்னொன்னு கூட சொன்னேன், கிரிக்கெட் வச்சு சொன்னேன், சேவாக் டிராவிட்னு சொன்னேன், ஞாபகம் இருக்கா? யார் கன்சிஸ்டன்ட் பிளேயர்னு? அது எஃப் டெஸ்டுக்கு தானே சொன்னேன். அது மறந்துட்டீங்களா? ஞாபகம் இருக்கா இல்லையா? ஓகே, சோ இந்த மாதிரி வேர் we want to test the variance, அதாவது வந்து dispersion டெஸ்ட் பண்றப்போ we are going to use F test for variance, அதாவது வந்து F test நம்ம யூஸ் பண்ணுவோம். ஓகேங்களா? ரைட். அது வந்து F test follows a F distribution. இது வந்து அதனுடைய test statistics வந்து F equal to S1 square divided by S2 square. The condition is always in the numerator, the bigger variance should be in the numerator. அதுதான் condition. Whenever we want to check the consistency, not the mean value, measures of dispersion compare பண்றப்ப we have to use F distribution. This will be used in testing of means. Okay, test for means க்கு வந்து எவ்வளவு test for means இருக்கு? We can have major 3, comparison of single mean, comparison of two means, and comparison of 3 or more mean values. These are the 3 situations we can apply test for means. Okay, right. So usually in our situation we may not going for comparison of single mean. So அது வந்து estimation சொல்லுவாங்க. அது வந்து நம்ம பண்ண போறது இல்ல majority-ஆ, but எப்பாச்சும் rare situationல பண்ணுவோம், that you can do it. And then comparison of two means, there are 2 situations. One is, what is the situation? If it is paired or unpaired. Okay, there are the 2 situations. The comparator groups are independent groups. So any example? நேத்து என்ன example சொன்னா? Comparing hemoglobin level between male and female இல்லையா? So அந்த மாதிரி situationக்கு வந்து independent sample t test use பண்ணனும். இந்த independent sample t test பண்ணும்போது there are some preconditions should be satisfied, assumptions should be satisfied. One of the assumption is definitely it should follow a normal distribution and the variance are equal. If the variance are equal, you have to straight away do the t test, student t test. If the variances are unequal, then you have to go for the modified t test. The another scenario, both the means are paired in nature or matched case, you have to go for the paired t test. There is no question of comparison of variances. Okay, there we are only comparing the differences. That's why the comparison of variance doesn't arise in the paired t test. Is it clear? Okay, right. Next, and also you should know that when you should use t test and when you should use Z test. So Z test comes across when the population variance is known and sample size is large. The scenario of population variance is known never arise because we don't know. We will never, in medical research, we will never do a complete enumeration. Okay, so the Z test concept is gone in our medical research. So only it will follow a t distribution, and normality assumption says that if the sample size too large, the t test itself assumes or approaches the Z test. Okay, so basically we are going to do only t test. Is it clear? Okay, now when the 3 or more mean values, we are going for one way ANOVA. Okay, is it clear? Right? And do you know how to interpret the output? t test ஓட output SPSS ல ரன் பண்றத வந்து இன்டர்பிரட் பண்ணனுமா வேண்டாமா? சோ வேண்டாம் நான் அஸ்யூம் பண்ணிக்கிறேன். ஓகே, thank you மேடம், நீங்க ஆரம்பிக்கலாம். நான் சொல்லிட்டேன் முதல்லயே, கேட்டா தான் கிடைக்கும்னு சொல்லிட்டேன், நீங்க யாருமே கேட்கல, கொடுக்கல. ஓகே, வேணும்னா சொல்லுங்க. பண்ணணுமா? ஓகே, ரைட். Okay, so I am going to analyze, compare means, independent sample t test. I am going to compare HTL between gender and also diastolic BP. So, now between gender, in the gender I have to define what is male and what is female. One represents male and 2 represents female. Continue, click OK. So whether the outputs are visible, you able to see it? Okay. So there will be two tables. First will be group statistics and second table will be our t-test. So in the first variable, so what is the diastolic, mean diastolic PP for male? What is the mean diastolic PP? And standard deviation is? So what about mean diastolic PP among female? So standard deviation? Okay. Right. Okay. So 1 minute. Okay. So it is not HDL. I want to compare triglycerides. Analyze, compare means test. Triglyceride. Yeah. Okay. So what is the mean triglyceride DGL among male? (158). Standard deviation 106. And female? And okay, so it may not follow normal distribution. 136 and standard deviation is 89. So there is a rule of thumb that if your standard deviation is more than half of your mean value, definitely it won't follow a normal distribution. Okay. So no, make a note of it. If your standard deviation is more than half of your mean, standard deviation more than half of your mean, you can strongly suspect that it won't follow normal distribution. Definitely it won't follow normal distribution, I can say, definitely. Okay. So in those situations you have to use non-parametric test. And the beauty of sapirovils or colmoglossimi now, the sample size is enormously large, like 350 and other things. All the variable doesn't follow normal distribution. It will show like that only. So up to sample size of 60, you can go for the sapirovils test or colmoglossimi test. And after that, you have to go with only this rule of thumb. Okay. Definitely, even if it is perfect, now you can select as random sample of 500 random sample from normal distribution, standard normal distribution, and then you can test for normality. It won't follow mostly. That's the power of your KS test when the sample size is too large. Okay. Right. Now, so this is the first table, tells your statistics, descriptive statistics. Then you have to go to the second table. So this is for illustrative purpose. Definitely the HDL won't follow. Sorry, TGL won't follow a normal distribution. We can check that later. Now, this is the second table. In this, you can give the output will describe about the testing of or comparison of mean values. Okay. So what is the first part? Levin's test for equality of variances. So what is the assumption while doing a t-test, independent sample t-test? Normally distributed and variances are equal. If the variances are equal, we have to do a student t-test. If it is unequal, modified t-test. So SPSS will give both the scenario, whether it is the equal variances are equal or unequal, it will give output for both the things. So you have to choose accordingly. For first the BP diastolic, what is the whether the variances are equal or unequal? What is the p-value here for Levin's test? What is the p-value for Levin's test for diastolic BP? What is the p-value? 0.633. So whether the variances are equal or unequal. So what is the null hypothesis there? What we are going to compare? We are comparing the variance of diastolic BP among male and variance of diastolic BP among female. So we are comparing two variances of diastolic BP between male and female. What is your null hypothesis? there is no significant difference in the variance of diastolic BP between male and female. Okay, the p value is 0.633. What will happen to your null hypothesis? Will you accept it or reject it? Accept it. So then what is the interpretation? What is null hypothesis? There is no significant difference in diastolic BP, difference in variance of diastolic BP between male and female. So in that case, variances are equal. So how can you say it is unequal? Simple logic, right? Unless otherwise, if you are not familiar with your null hypothesis, you may not be able to take a strong decision. Okay? Please keep in your mind that the software will give you the p value, but the formation of null hypothesis lies within you. That you have to frame the null hypothesis perfectly, correctly. Otherwise, you will end up in interchanging the results. Okay. Now here the variances are equal. Then you have to go with equal variance assumed. Then next column, t test for equality of means. So what is the p value there? Significant two-tailed 0.531. That p value you have to choose. You should not use 0.535. Okay. Is it clear? Next, come to the triglyceride scenario. So what is the test for variance says? What is the p value? What is the p value, sir? What is the p value? Huh? Net absent. இல்ல இப்ப சொல்லுங்க. What is the p value here? First நான் explain பண்ணனும்ல. Okay, what is the p value? 0.019. Will you accept the null hypothesis or reject the null hypothesis? You have to reject null hypothesis since it is less than 0.05. So what is your interpretation? Variances are unequal. So in that case, equal variances not assumed. Then what is the p value for comparison of two mean values? 0.057. Okay. So this is how you have to interpret the output of the. Okay. Is it clear? I think both the scenario we have discussed. Do you need any more explanation? We'll stop. Okay. Okay. Thank you, ma'am.
And it should follow a normal distribution. Then n is less than 30. நீங்க பண்ற ஸ்டடியில நிறைய பாத்தீங்கன்னா n வந்து 10, n வந்து 5 அப்படி எல்லாம் பண்றீங்க. Then you are doing parametric test. That is absolutely wrong. சரியா? When n is less than 30, straight away you go to non-parametric test. ஆனா பாத்தீங்கன்னா எது வந்து parametric test more efficient, non-parametric test more efficient. That also you should not forget. That's why we ask you to take sample size greater than 30. இப்போதான் கொஞ்சம் உங்க ஸ்டடிக்கு greater than 30 எடுத்துட்டு வந்திருக்கிறீங்க. Sometimes you go only for 5. அப்போனா your results are not robust. அது வந்து ஸ்ட்ராங்கா நீங்க சொல்ல முடியாது. So parametric test is more strong, more robust than non-parametric test. நிறைய பேர் என்ன தெரியுமா செய்வாங்க, இது non-parametric வந்து குவிக்கா பண்ணிடலாம். குவிக்கா பண்ணிடுறதுனால என்ன செய்வாங்க, parametric test பண்ண முடியும், ஆனாலும் they will be doing non-parametric test. That you should not do. Okay, so always keep in mind, இதுனா இதுக்கு alternative non-parametric test கொஞ்சம் தான் நான் போட்டிருக்கேன். That only is for your examination point of view. We are not going to go beyond that. அப்படின்னா எனக்கு ஃபுல்லா சொல்லி கொடுத்துட்டே இருக்கணும். Okay, so it's like teaching statistics and teaching SPSS. மேடம் சொல்லணும், டாக்டர் சுப்பா மேடம் அடுத்த தடவைலாம் வந்து இந்த மாதிரி எல்லாம் பண்ணீங்கன்னா you will not learn perfectly. ஏன்னு சொன்னா it's under the assumption that you know statistics and we are doing SPSS. Okay, சொல்லி கொடுத்ததே தெரியலன்றீங்க. சரியா? Now you look at this table. Parametric test, non-parametric test. So assumption are made about the population parameter, and n is greater than or equal to 30 we will do. Applied when the distribution is normal. நான் எல்லாத்தையும் கொண்டு வந்து ஒரே டேபிள்ல போட்டுருணும் அப்படின்னு சொல்லி then only you can compare. இப்படி பார்க்க ஈஸியா இருக்கும்னு சொல்லிட்டு I brought it here. So you remember. So non-parametric testல என்ன பண்றோம்? No assumptions are made about the population parameter, non-normal or skewed. When n is less than 30, we go for non-parametric test. It's the basic, you should never forget. Okay, so handles interval or ratio level data. இங்க பாத்தீங்கன்னா ordinal, nominal, interval, ratio level and ranked data. Rank பண்ண scores அதெல்லாம் நீங்க வந்து ஒரு 10 வச்சுட்டு you are doing something. You should never do that. Okay, measures of central tendency இங்க மீன் அதை பார்க்குறோம். Whereas இங்க வந்து skewed-ஆ இருக்கிறதுனால we normally see median. Okay, have more statistical power. So not more powerful statistically. Non-parametric test வந்து it's not powerful and not strong enough. Okay, the results can be affected by the outliers. இங்க outliers இருந்ததுன்னா கண்டிப்பா parametric test will get affected. Okay, இங்க வந்து you needn't bother about anything. கண்ணை மூடிட்டு 5 தான் பண்ணிருக்கீங்கன்னா go for non-parametric test. But you should keep all these things in your mind. Okay, இங்க variable and attributes we will be looking. சரியா? இப்ப பாருங்க, I brought everything in another table. Parametricல independent t-testனா non-parametricல you have to go for Mann-Whitney U-test or Wilcoxon rank sum test. ரெண்டும் ஒண்ணுதான். ஓகே, இங்க பாத்தீங்கன்னா ஒரு எக்ஸாம்பிள் கொடுத்துருக்கேன். The blood pressure levels in 2 different groups of patients. One group is treated with a new medication and the other group is treated with a placebo. So ரெண்டு medications இருக்கு to test if the medication group has significantly different blood pressure readings compared to the placebo group. So ரொம்ப கஷ்டப்பட்டு படிக்க வேண்டியதா இருக்குது because I have put it in a same table so that it will be easy for you to compare. சரியா? So independent t-test na alternative when you have a small sample கண்ணை மூடிட்டு இங்க போயிடுங்க, Mann-Whitney U-test க்கு போயிடுங்க. And this is an example. Okay, paired na Wilcoxon signed rank test. இதையும் கன்ஃபியூஸ் பண்ணுவாங்க. இந்த சைன் எப்போ வரும்னா before and after treatment difference கண்டுபிடிக்கும் போது you will get a sign. Okay, so paired t-test na you will have Wilcoxon signed rank test. நிறைய பேர் இதையும் மாத்தி எழுதிடுவாங்க. So be careful. Sign comes when you have a reading before and after treatment. So here a researcher wants to test if there is a change in the cholesterol levels of patients before and after taking a new drug. The cholesterol levels of the patients are measured before and after the treatment. So if you want to test whether the variation is significantly different, then we go for, in a non-parametric we will be using Wilcoxon signed rank test. In a parametric we will be using paired t-test. So mindல பின்னாடி இருக்கணும், parametric test na என்னது, non-parametric test na என்னது. Simply I have given an example. You should keep n is greater than 30. It should follow a normal distribution. இதெல்லாம் நீங்க இங்க ஆட் பண்ணிக்கணும். When it is for parametric, when it is for non-parametric. ஒரே ஒரு இடத்துல I have given n. Then one way ANOVA. சரியா? ஜென்ரலா ANOVAன்னு சொன்னாலே மோஸ்ட்லி ஒன் வே இல்ல இருக்கட்டும் வந்து வரேன். ஸோ அதுக்கு ஈக்குவலன்ட் நான் பாராமெட்ரிக் வந்து Kruskal-Wallis test. Don't forget this. So you are comparing the effectiveness of 3 different treatments. More than 2 வந்துச்சுனாலே means a test பண்ணனும்னா you have to go to ANOVA. சரியா? அப்புறம் வந்து so you are comparing the effectiveness of 3 different treatments A, B and C on lowering blood pressure levels in a diabetic patients. Repeated measures of anomana equivalent வந்து non-parametric வந்து Friedman test. So a researcher wants to test the effect of 3 different diets on weight loss in the same group of patients over 3 months. Repeated na one patient has been repeated several times and the results are observed using different treatment. So you keep in mind repeated vandale adu vandu it is a paired situation. You can't call it as a pair, but several times it has been repeated. The treatment has been repeated for the same patient. Okay. Then Pearson rank correlation and Spearman rank correlation test. இதுக்கு வந்து equivalent வந்து இது that Nandini will be taking. உங்களுக்கு இன்னும் அந்த portion வராததுனால what do you mean by Pearson rank correlation and Spearman rank correlation? So when the parametric test is Pearson rank correlation, the alternative non-parametric is Spearman rank correlation coefficient. இங்க என்ன பண்றாங்கன்னா researcher wants to investigate the relationship between exercise duration in minutes per day and weight loss in a group of, I have put here 10. So this is for non-parametric, and if you increase, it may go for the parametric. The researcher wants to see if longer exercise duration are associated with greater weight loss. So association அப்படினாலே correlation வந்துரும். So parametric na you call it as Pearson rank correlation coefficient. For non-parametric, we will call it as a Spearman rank correlation coefficient. You are not going to tell any formula. That is your syllabus you will be studying. Here, எதுக்கு யூஸ் பண்றோம், இதுக்கு ஆல்டர்னேட்டிவ் என்ன. So for your dissertation work, this will be very useful. மாத்தி பண்ணீங்கன்னு வச்சுக்கோங்க, நிறைய பேர் வராங்க, இதுக்கு அதை பண்ணுங்கன்னு சொன்ன they will never get convinced. அங்க போயிட்டு ஐஇசில போய் திட்டு வாங்கிட்டு வரீங்க. ஓகே, so be careful. சொன்னா அதையும் கேட்கணும், why I am saying that அப்படின்னு சொல்லிட்டு. ஓகே, இங்க வந்தீங்கன்னா இந்த போஸ்ட் ஹாக் டெஸ்ட், இது வந்து டன்ஸ் டெஸ்ட் தான் மோஸ்ட்லி யூஸ் பண்றோம் நம்ம. 2 other டெஸ்ட் பூபதி வாஸ் மென்ஷனிங். உங்க சிலபஸ்ல டன்ஸ் டெஸ்ட் இருக்கு. போஸ்ட் ஹாக்னாலே மோர் தென் 2 groups அங்க இருக்கு. ஸோ எந்த குரூப் பேர் வைஸ் பார்க்கும்போது எந்த குரூப் சிக்னிஃபிகண்டா இருக்கு, இல்லை எல்லாமே சிக்னிஃபிகண்டா இருக்கான்னு பார்க்கறதுக்கு தான் we use post hoc test. Generally it will give a result. Overall it is significantly different ன்னு கொடுக்கும். Reject the null hypothesis ன்னு கொடுக்கலாம். But within you have several groups. 3 group இருக்கு. எந்த 2 group வந்து significantly different? If you want to do that, you have to do a post hoc test. அது எதுனாலும் சரிதான், Friedman testனாலும் சரிதான், Kruskal Wallis also you have. ஸோ எதுனாலும் போஸ்ட் ஹாக் பண்ணுன்னு சொன்னா அதுதான் மீனிங். எந்த 2 குரூப்ல சிக்னிஃபிகண்ட், ஓவரால் சிக்னிஃபிகண்ட் தெரிஞ்சிருச்சு, பட் எந்த 2 குரூப் டர்ன்ஸ் அவுட் டு பி சிக்னிஃபிகண்ட், தேர் ஒன்லி கம்ஸ் தி போஸ்ட் ஹாக். சரியா? So now we will be seeing one more thing, chi-square test. This is widely used. It is a statistical test used to determine whether there is a significant association between 2 categorical variables. It compares the observed frequency of events in each category of the frequencies expected under the null hypothesis, which states that the variables are independent. So now we will see a problem. A researcher wants to investigate if there is an association between smoking status, that is smoker versus non-smoker, and the presence of lung disease, diseased versus healthy. சரியா? I have put it in a very simple word. Normally we will never write in statistics, but I want you to understand. That's why I have gone to very low level of explaining. சரியா? you will be using a test, and suppose you get a p-value of 0.01 is less than the significant level of 0.05, we reject the null hypothesis. Always keep in mind, if the p-value is less than 0.05, we will reject the null hypothesis. Okay, so and conclude there is a significant association between smoking status and the presence of the lung disease. So smoking is associated with a higher likelihood of lung disease. This is the example. So this is smoking status. Evlo smokers irukkranga with the disease, and there are 40 members with the disease who smoke, and 60 healthy persons are there, participants of the study, but still they are smoker, but they are free from the disease. Non-smoker la pathina ivlo per 20 members are there. So we want to test whether really the smoking status is associated with the lung disease. Adhan nammaloda aim. Looking at this data or putting some percentage, it will not work. So we have to use a chi-squared test. Chi-squared test is a non-parametric test. Okay. Oh. So one more thing, Fisher's exact test. So when a cell, I previously was showing smokers, non-smokers, so when a cell value is less than 5, any cell value, we call this each cell. Okay, any one of the cell value is less than 5, you have to go for Fisher's exact test rather than chi-square test. That automatically it will give. So SPSS will give n number of things, but you have to select it properly. If you have the understanding and if you have the knowledge, you will be able to do that. Okay. So, so they have done the Fisher's exact test, and that Bhubadi will be explaining how to get this. Within a single click, you will get all these things. So here the p-value is 0.38, greater than the significance level. So you fail to reject the null hypothesis, conclude there is no significant association between receiving the drug and the current side effects. The side effects appear to be independent whether a patient receives the drug or placebo. So here the treatment is receiving a siddha drug and no drug, a placebo, maybe a saline, something like that. Then the side effects, yes. Side effects, no. So this is how you should classify into 2 table. So here you can see the cell values are less than 5. Less than or equal to 5. One of the cell value among these 4 is less than 5. You have to go for a Fisher's exact test. So you have to just pick the result from the output. Then you say, since this cell value is less than 5, I am looking at the Fisher's exact test, and this is the conclusion. Okay. So in non-parametric, if you are thorough with these tests, you can do wonders in your dissertation. Okay. Don't say my seniors has done, so I am doing the same parametric test. They will come and talk to me. I don't know what to say. I will say, you consult your HOD and do whatever you want. Okay, so you should be strong enough to say what is right and what you should not do. Okay, so that's all. So any doubts in this non-parametric test? Already I have given you assignment in Subhadra, Kutrukingla, Panningla. Okay, so if you have any doubt, you can ask me. Okay, I am not taking much of your time. Hands on பண்ணவே முடியாது. இது you can search and you can find out where in the even YouTube they give a lot of lectures. So hands on is very important. Okay, so this is about that. And கூடாது. நார்மல்
காரிலேஷன் என்ன நினைக்கிறீங்க? Between two variables. So relationship between two variables. Two variables na enna solvona bivariate nu solvom. சரியா? ரெண்டு வேரியபிள்ஸ்க்கு உண்டான ரிலேஷன்ஷிப் பாக்குறது. ஏதாவது ஒரு எக்ஸாம்பிள் சொல்லுங்களேன். ரெண்டு வேரியபிள்க்கு உண்டான ரிலேஷன் பாக்குறதுன்னு சொன்னீங்க இல்லீங்களா? எதுவும் சம்பந்தப்பட்டு இருக்கும் யூசுவலாவே நம்ம டே டு டே லைஃப்ல. ஸ்மோக்கிங் அண்ட் லங் கேன்சர், சாரி, alcohol and liver disease. Then ரொம்ப டிசீஸா போக வேண்டாம், பேசிக் ஹைட் வெயிட்ல வச்சுக்கோங்க. ஹைட் வெயிட் ஏஜ் வச்சுக்கோங்க. ஹைட் வெயிட் ஏஜே வச்சுக்கோங்க. வயசு ஆக ஆக ஹைட் வளருமா வளராதா? என்னமா? The height will also increase. So as age increases and the height will also increase till a certain age. Am I right? The same way as age increases, weight will also increase. Am I right? Correct me if I'm wrong, okay? ஏன்னா நான் biostatistics student, medical example ஏதாவது தப்பா இருந்தா நீங்க சொல்லுங்க, நான் தெரிஞ்சுக்கிறேன். ஓகே, diastolic systolic BP ஏதாவது ஒண்ணு குறைஞ்சா இன்னொன்னு எதுவுமே ஆவாதா? சிஸ்டாலிக் சத்தமா சொல்லுங்க, அப்பதான் எனக்கு கேட்கும். சாரி, ஓகே. சோ பிபி ஏதாவது ஒண்ணு குறையுது அல்ல அதிகமாகுது அப்படின்னா அவங்க ஒரு டிசீஸ்க்கு டெண்ட் ஆவாங்களா மாட்டாங்களா? they will be diagnosed as hypertensive, right? So என்னென்ன இதுல வந்து காரிலேஷன் யூஸ் பண்ணலாம் அப்படின்றத நம்ம சின்ன எக்ஸாம்பிள்ஸ் வச்சு பார்க்கலாம். ஸோ நம்ம பேசின மாதிரி காரிலேஷன்னா ஒரு ரெண்டு வேரியபிள்க்கு உண்டான ரிலேஷன்ஷிப் பார்க்கறது பிளஸ் அசோசியேஷன் பார்க்கலாம். we can connect, we have a connection or any form of relationship. So defines as reciprocal relationship between two or more things. The variables are said to be correlated if the change in one variable results in corresponding change in other variable. So இப்போ diastolic dystolic PP நம்ம கிட்ட இருக்கு. எது குறைஞ்சா அவங்களுக்கு ஹைப்பர்டென்ஷன் வரதுக்கான வாய்ப்பு அதிகமா இருக்கும்? ஹைப்பர்டென்ஷன் குறைஞ்சா ஹைப்பர்டென்ஷன், அதிகமானா ஹைப்பர்டென்ஷன். ஸோ அவங்க வந்து இப்போ நம்ம பிபி செக் பண்றோம், அதுல ஏதோ நம்மளுக்கு வந்து அதிகமாக ஆக அவங்க ஹைப்பர்டென்ஷன் பேஷண்ட்ஸும் அதிகமாவாங்க. ஸோ இங்க தேர்ட் பாயிண்ட், the variables are said to be correlated if the change in one variable. பிபி லெவல்ல சேஞ்ச் இருந்தா அவங்களுக்கு ஹைப்பர்டென்ஷன் அதிகமாகிறதுக்கான வாய்ப்பு இருக்கு. ஓகே, ஸோ கார்லேஷன் வந்து ஸ்ட்ரென்த் ஆஃப் ரிலேஷன்ஷிப் எப்படி சொல்லுவாங்கன்னா கார்லேஷன் பொறுத்த வரைக்கும் -1 இருந்து +1 வரைக்கும் போகும். சரியா? எல்லாருமே மேக்ஸ் படிச்சிருக்கீங்க இல்லையா? மேக்ஸ்ல இந்த எலிப்ஸ் டயக்ராம் பாராபோலா அப்புறம் வந்து 4 குவாட்ராட்டிக் கிராஃப்லாம் பார்த்துருக்கீங்களா? ஸோ அது பேசிக் ரிலேஷன்ஷிப் வச்சு நம்ம இங்க பார்த்துக்கலாம். ஸோ நம்மளுக்கு என்னன்னா மைனஸ்ல இருந்து இன்ஃபினிட்டில ஆரம்பிச்சு +∞ வரைக்கும் போகுமா? எக்ஸ் ஆக்சிஸ் ஒய் ஆக்சிஸும் அதே மாதிரி போகுமா? ஸோ இங்க வந்து நம்ம -2 to 1, மைனஸா இருந்தா நெகட்டிவ் கார்லேஷன், பிளஸ்ஸா இருந்தா பாசிட்டிவ் கார்லேஷன், ஜீரோவா இருந்தா there is no correlation. பேசிக் அதுதான். ஓகே, ஸோ பாசிட்டிவ் கார்லேஷன், பாசிட்டிவ் நம்பர்ஸ் இருந்தா அந்த இடத்துல என்ன சொல்லுவாங்க அப்படின்னா இட் இஸ் டைரக்ட்லி ரிலேட்டட். ஸோ இன்க்ரீஸ் இன் பிபி இஸ் டைரக்ட்லி ரிலேட்டட் டு ஹைப்பர்டென்ஷன் அண்ட் டிக்ரீஸ் இன் பிபி இஸ் ரிலேட்டட் டு ஹைப்போடென்ஷன். டைரக்ட்லி அண்ட் இன்டைரக்ட்லி வந்து நம்மளுக்கு கனெக்ட் ஆகிற ஒரு விஷயமும் வந்து கார்லேஷன் இருக்கு. ஓகே, புரியுதா? புரியலன்னா நான் ஸ்டாப் பண்ணுங்க, நான் எக்ஸ்பிளைன் பண்றோம். ஓகே, ஸோ பாசிட்டிவ் கார்லேஷன், நெகட்டிவ் கார்லேஷன் முன்னாடி சொன்ன மாதிரி டைரக்டா கார்லேட் ஆகிறது வந்து பாசிட்டிவ் கார்லேஷன், இன்வெர்ஸ்லி கார்லேட் ஆகிறது வந்து நெகட்டிவ் கார்லேஷன். ஸோ சேஞ்ச் த வேல்யூஸ் ஆஃப் டூ வேரியபிள் சேஞ்சிங் இன் த சேம் டைரக்ஷன். அதாவது ஹைப்பர் டென்ஷன் இன்க்ரீஸ் வந்து நம்ம எக்ஸ் ஆக்சிஸ்ல வச்சுக்கிறோம்னு வச்சுக்கோங்களேன். ஒய் ஆக்சிஸ்ல வந்து ஹைப்பர் டென்ஷனுக்கு உண்டான கவுண்ட்ஸ் ஏதோ ஒன்று இன்க்ரீஸ் ஆகுது. ஸோ இது இன்க்ரீஸ் ஆக 1 2 3 4 அது இன்க்ரீஸ் ஆக இங்க பேஷண்ட்ஸோட லெவலோ இல்லை அந்த ஹைப்பர் டென்சியோட லெவலோ வந்து அதிகமாச்சு அப்படின்னா உங்களுக்கு இது பாசிட்டிவ் கார்லேஷன். ஸோ டயக்ராம் வந்து உங்களுக்கு இந்த மாதிரி இருக்கும். ஸோ இப்படி போகும்போது இட் இஸ் பாசிட்டிவ் கார்லேஷன். ஓகே, ஸோ இதுவே இன்வெர்ஸா போச்சு அப்படின்னா அது நெகட்டிவ் கார்லேஷன். ஓகே, ஸோ எக்ஸாம்பிள் வந்து height and weight as age increases, height tends to increases until a certain point. நம்ம ரைட் ஒரு 20 வயசு வரைக்கும் தான் வளர்ச்சி நம்மளுக்கு இருக்குதுன்னா சின்ன வயசுல இருந்து அந்த வளர்ச்சி இருக்கணும். அது பாசிட்டிவ் கார்லேஷன். நெகட்டிவ் கார்லேஷன்னா இன்க்ரீஸ்ட் ஸ்ட்ரெஸ் கிவ் அ டிக்ரீஸ்ட் இம்யூன். யாரெல்லாம் ஒத்துப்பீங்க இது? நான் அக்செப்ட் பண்ணுவேன். ஸ்ட்ரெஸ் லெவல் இன்க்ரீஸ் ஆக இம்யூன் பவர் பாடியில இருக்கிறது ஆட்டோமேட்டிக்கா குறையும். ஸோ இதுதான் உங்களுக்கு ஸ்ட்ரென்த் ஆஃப் ரிலேஷன்ஷிப்க்கு உண்டான ஸ்கேட்டர் பிளாட் சொல்லுவாங்க. இது ஒரு டயக்ராம். ஸோ இதை வச்சு நம்மளுக்கு வந்து கார்லேட் ஆயிருக்கா, பாசிட்டிவா கார்லேட் ஆயிருக்கா, நெகட்டிவா கார்லேட் ஆயிருக்கான்னு நம்மளால ஐடென்டிஃபை பண்ண முடியும். ஸோ ஃபர்ஸ்ட் இமேஜ் வந்து பெர்ஃபெக்ட் நெகட்டிவ் ரிலேஷன்ஷிப். ஸோ இதோட லைன் பார்த்தீங்கன்னா உங்களுக்கு இன்வெர்ட்லி இருக்கு. ஸோ யூ ஹேவ் ஒய் ஆக்சிஸ் அண்ட் எக்ஸ் ஆக்சிஸ். உங்களோட ஆக்சிஸ் பார்த்தீங்கன்னா கீழே அந்த லைன் பார்த்தீங்கன்னா உங்களுக்கு டவுன்வர்ட்ல போகுது. ஸோ இட் இஸ் நெகட்டிவ்லி கார்லேட்டட். அதே வந்து நோ ரிலேஷன்ஷிப் பார்த்தீங்கன்னா அந்த இடத்துல எந்த ஒரு லைன் ட்ரெண்டும் இல்லை. ஓகே, தென் பாசிட்டிவ் ரிலேஷன்ஷிப் ஆஸ் ஐ செட் எக்ஸ் ஆக்சிஸ் இன்க்ரீஸ் ஆச்சுன்னா ஒய் எக்ஸ் வேரியபிள் இன்க்ரீஸ் ஆச்சுன்னா ஒய் வேரியபிள் இன்க்ரீஸ் ஆகும். ஓகே, ஸோ இங்க 2 கார்லேஷன் கோஎஃபிஷியன்ட்ஸ் இருக்கு. ஒன்னு பியர்சன் கார்லேஷன், இன்னொன்னு ஸ்பியர்மேன் கார்லேஷன். வாட் இஸ் பியர்சன் கார்லேஷன்? பேசிக்கா பாராமெட்ரிக் மேம் இப்ப சொன்னாங்க சார் கிளாஸ்ல. பாராமெட்ரிக் டெஸ்ட். ஓகே, இது நான் பாராமெட்ரிக் டெஸ்ட். இதுல ஸ்பியர்மேன் கார்லேஷன். பியர்சன் கார்லேஷனோட ஆல்டர்னேட்டிவ் தான் ஸ்பியர்மேன் கார்லேஷன். ஓகே, ஸோ இது வந்து பியர்சன் கார்லேஷன் வந்து இட்ஸ் அ வைட்லி மெஷர்ட். அதாவது அந்த கார்லேஷன் தான் எல்லா இடத்துலயுமே மோஸ்டா யூஸ் பண்ணுவாங்க. ஓகே, ஸோ இதுக்கு இந்த கார்லேஷன் யூஸ் பண்றதுக்கு டேட்டா வந்து கண்டினியூஸ் வேரியபிளா இருக்கணும். ஸோ நேற்று நம்ம பார்த்தோம் இல்லையா, கண்டினியூஸ் டிஸ்கிரீட்லாம் பார்த்தோம்ல. நீங்க அன்றாட டெஸ்டிங்கோ இல்லை ஒரு நார்மல் வைட்டல் ஸ்டாட்டிஸ்டிக்ஸ் பார்க்கும் போது அதுல ரெகுலரா பார்க்குற கண்டினியூஸ் வேரியபிள் என்ன? ஹைட், வெயிட், அப்புறம் கேட்கல, பல்ஸ் ரேட், அப்புறம் டெம்பரேச்சர். ஸோ ஏதாவது ஒன்னதோட ரிலேட் பண்ணி சொல்லுங்களேன். பல்ஸ் ரேட் இன்க்ரீஸ் ஆகுது, அதனால அவங்களுக்கு இது இன்க்ரீஸ் ஆகும். ஹார்ட் ரேட், அப்புறம் வேற எக்ஸாம்பிள். பல்ஸ் ரேட், ஹார்ட் ரேட் முடிஞ்சிருச்சு. வேற சாரி, பல்ஸ் ரேட் அண்ட் ஃபீவர். ஓகே, டெம்பரேச்சர் ஹை ஆகும்போது பல்ஸ் ரேட் ஹை ஆகும். தென் ஓகே, ஸோ இந்த மாதிரி கண்டினியூஸ் வேரியபிளா இருக்கும் போது நம்ம வந்து பியர்சன் கார்லேஷன் யூஸ் பண்ணலாம். இதுல பாராமெட்ரிக் டெஸ்ட்ல பேசிக்கா உங்களுக்கு என்ன அசம்ஷன் இருக்கணும்? நார்மாலிட்டி. ஸோ இட் இஸ் யூஸ்ட் வென் போத் த வேரியபிள்ஸ் ஆர் நார்மலி டிஸ்ட்ரிபியூட்டட். ஓகே, ஸோ இது வந்து ப்ராடக்ட் மெத்தட், மொமெண்ட் மெத்தட்னு சொல்லுவாங்க. நம்ம எக்ஸ் அண்ட் ஒய் வேரியபிளை வந்து நம்ம ப்ராடக்ட் பண்ணி ஆறுன்ற ஒரு வேல்யூ கால்குலேட் பண்ணுவோம். அந்த ஆறுன்றது தான் பியர்சன் வேல்யூ. ஸோ நான் ஜஸ்ட் ஃபார்முலா வந்து தெரிஞ்சுக்கிறதுக்காக போட்டிருக்கேன், யாரும் பயப்பட வேண்டாம். ஓகே, ஸோ நெக்ஸ்ட் அசம்ஷன் என்னென்ன? வேரியபிள்ஸ் ஆர் அஸ்யூம் டு பி இண்டிபெண்டன்ட். இதை டிபெண்ட் பண்ணி இது இல்லை, அந்த மாதிரி ஒரு வேரியபிள் இண்டிபெண்டா இருக்கும். தென் வேரியபிள் ஷுட் பி மெஷர்ட் as on a continuous scale. Data should not contain outliers in either variables. ஸோ இப்போ ஹார்ட் ரேட், பல்ஸ் ரேட் நீங்க ரெக்கார்ட் பண்றீங்க, ஹைட், வெயிட் ரெக்கார்ட் பண்றீங்க. அவுட்லயர்ஸ்னா என்ன? எக்ஸ்ட்ரீம் வேல்யூஸ். ஹார்ட் ரேட் 200 போகுமா? பல்ஸ் ரேட் போகும், ரேர். ஸோ அந்த மாதிரி ரேரா வந்து போகப்ப அந்த அவுட்லயர்ஸ் இல்லாம இருந்தா we can go for it. That is an assumption. இது வயலேட் ஆகுது அப்படின்னா, இங்க இருக்கிற அசம்ஷன் வயலேட் ஆகுது அப்படின்னா we'll go for some பியர்சன் கார்லேஷன். புரியுதா? இதுல ஏதாவது ஒன்று சாட்டிஸ்ஃபை ஆகலைன்னா கூட we'll go for a பியர்சன் கார்லேஷன். அதாவது நான் பேராமெட்ரிக். புரியுதுங்களா? ஓகே ஓகே. The strength of association of the variable depends on what you measure and the sample size. So இங்க strength of association பாத்தீங்களா, ஸ்மால், மீடியம், லார்ஜ் இருக்கு. ஸோ பாசிட்டிவ் பொறுத்த வரைக்கும் 0.1, அதாவது -1 to +1 இருக்குன்னு சொன்னேன். ஸோ 0ல இருந்து 1 வரைக்கும் தான் நம்மளுக்கு அது வந்து பாசிட்டிவ் கார்லேஷனா இருக்கும். ஸோ ஸ்மால் பாசிட்டிவ், அதாவது ஸ்ட்ரென்த் ஆஃப் அசோசியேஷன் வந்து கம்மியா இருக்கு, மீடியமா இருக்கு, லார்ஜா இருக்கு அப்படின்றது வந்து இந்த வேல்யூஸை வச்சு நம்ம சொல்லிக்கலாம். ஓகேவா? அதே மாதிரி நெகட்டிவ் கார்லேஷனும் அதே மூலதான். ஸோ -0 to -1 வரைக்கும் ஸ்ட்ராங்கானா அந்த -1 வர வரைக்கும் நம்ம ஸ்ட்ராங்னு சொல்லிக்கலாம். So the closer the scatter plot line next to the line, the stronger the relationship between the variable. இந்த scatter plot இருக்குல்ல, லைன் இருக்குங்களா, லைனை சுத்தி ஒரு குட்டி 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 பிளாட்ஸ் தெரியுது இல்லைங்களா, அது வந்து எவ்வளோக்கு எவ்வளோ அந்த லைனுக்குள்ள க்ளோஸரா இருக்கும். அந்த ஒரு பிளாட்டுமே வந்து ஒரு பேஷண்ட்டை ரெப்ரசென்ட் பண்றதுன்னு அர்த்தம். ஸோ அது ஒண்ணு எவ்வளோக்கு எவ்வளோ அந்த ஸ்ட்ரெயிட் லைனுக்குள்ள கிட்ட இருக்கோ அவ்வளோக்கு எவ்வளோ ஸ்ட்ராங்கர்னு சொல்லுவாங்க. ஓகே, தென் ஸோ அதேதான், இட் கேன் பி ரேஞ்சஸ் ஃப்ரம் -1 to +1. ஓகே ஓகே. ஒரு சின்ன கொஸ்டின், இஸ் தேர் a positive correlation between BMI and systolic BP? இதுக்கு நல்ல ஹைபோதீசிஸ் யாருன்னா சொல்லுங்க. எவ்வளவு சீக்கிரம் சொல்றீங்களோ அவ்வளவு சீக்கிரம் ஆன்சர் போயிடலாம். கிடையாதா? கார்லேஷன் கிடையாதா? சரி, நல்ல பத்தி சொல்லுங்க. இந்த பேசிக் கொஸ்டின் வச்சுக்கோங்க. கார்லேஷன் இல்லைன்னா பரவாயில்ல, சொல்லுங்க. ஓகே, there is no correlation between BMI. அது என்ன hypothesis? அது நல்ல hypothesis. Alternative will be there is some relationship. So this is the hypothesis. So next நான் போறேன். இது ஒரு சின்ன டேட்டா செட், ஜஸ்ட் ஃபார் எக்ஸாம்பிள் நீங்க பாத்துக்கோங்க. சோ இது என்ன சொல்லுது? there is a strong positive correlation. கரெக்டா? சோ இதோட வேல்யூ என்னன்னு பாத்தீங்கன்னா R is equal to +0.88, which is 0 to 1. It is a positive correlation and it is stronger positive correlation. Am I right? So it is a strong positive correlation. Next, negative correlation. Is there any correlation between BMI and systolic BP? There will be no. So hypothesis வந்து அதே மாதிரி தான். There is no correlation and there will be some correlation. So இதுதான் data set, just for an example. So உங்களுக்கு இந்த plot என்ன சொல்லுது? There is a negative correlation. So நம்ம வேல்யூ பாத்தீங்கன்னா R is equal to -0.98. So it is strongly negative correlation. ஓகேவா? So இங்க பாத்தீங்கன்னா ரெண்டு வேரியபிளும் கண்டினியூஸா இருக்கு. ஓகே, so Pearson correlation யாருன்னா புரியாம இருக்கீங்களா? Okay, we'll go for Spearman correlation. So Spearman rank correlation is a non-parametric correlation, parametric test, sorry. So it doesn't have any assumption. இதுல வந்து நீங்க நார்மாலிட்டி பார்க்கணும்னு இல்ல, அவங்க கண்டினியூஸா இருக்காங்கன்னா இல்ல. முன்னாடி என்னென்ன அசம்ஷன் நம்ம பாராமெட்ரிக் டெஸ்ட், அதாவது பியர்சன் கார்லேஷன்ல பார்த்தோமோ அது ஸ்பியர்மேன் கார்லேஷன்ல இருக்கணும்னு இல்லை. ஓகேவா? அங்க ஏதாவது வயலேட் ஆகுதுன்னா நம்ம ஆட்டோமேட்டிக்கா ஸ்பியர்மேன் கார்லேஷனுக்கு போறோம். ஓகேவா? ஸோ இது வந்து அதோட ஃபார்முலா. அண்ட் ஸோ ஆர்டினல் மோஸ்ட் சாட்டிஸ்ஃபைட் டு லீஸ்ட் சாட்டிஸ்ஃபைட். ஸோ எனக்கு தெரிஞ்சு நம்ம சித்தா இன்ஸ்டியூட்ல ஒரு மினி ப்ராஜெக்ட்ஸ் பண்ணுவீங்க இல்லையா? அந்த மினி ப்ராஜெக்ட்ல மோஸ்டா நீங்க வந்து இந்த ஸ்கேல்ஸ் வச்சுதான் பண்ணுவீங்கன்னு நான் கேள்விப்பட்டிருக்கேன். 0, 1, 2, 3 ஸ்ட்ரகிள், அக்ரி, அக்ரி, டிஸ்அக்ரி அப்படின்னு சொல்லிட்டு ஸ்கேல்ஸ், நம்பர் ஆஃப் லைக் லிகட் ஸ்கேல்ஸ் மாதிரி சொல்லுவாங்க. 0 to 5, 0 to 10 மாதிரி. ஸோ மோஸ்டா யூ கேன் கோ ஃபார் ஸ்பியர்மேன் கார்லேஷன் while you using a ordinal scales if you have a ordinal scale data. Okay, so இது வந்து என்ன சொல்லுவாங்கன்னா monotonic. Calculating Spearman requires the two variable to have a monotonic relationship. Monotonic relationship அப்படின்னா ஏதாவது ஒன்று இன்க்ரீஸ் ஆச்சுன்னா இன்னொன்று டிக்ரீஸ் ஆகும். ஓகேவா? ஸோ அது வந்து என்னன்னா ஒரு வழியா அது இன்க்ரீஸ் ஆகுது இல்லை டிக்ரீஸ் ஆகுனா ஆட்டோமேட்டிக்கா அதோட இன்வர்ஸ் ரிலேஷன்ஷிப்பா தான் இருக்கும் இன்னொரு வேரியபிளுக்கு. அதுதான் மோனோடானிக்னு சொல்லுவாங்க. ஸோ இங்க பாத்தீங்கன்னா இது மோனோடானிக். ஒரு இடத்துல வந்து ஒரு ஆக்சிஸ்ல there is an increased trend and இன்னொரு ஆக்சிஸ்ல there is a decreased trend. So that is monotonic. அந்த ரெண்டு curves இருக்குல first ரெண்டு. Next non monotonicனா we will be having a curve. அவ்வளவுதான். So same way it should be ranging from -1 to +1. A positive correlation is when one variable increases and the other tends to increase, and negative correlation அதேதான். So Spearman correlation ஓட ஒரு சின்ன example. So there is there any significant correlation difference between disease severity and patient pain level? So disease severity score இங்க இருக்கு, patient level இருக்கு. நம்ம என்ன பண்ணுவோம் அப்படின்னா we'll be having a data set as we had in a Pearson correlation. So அங்க வந்து normal distribute ஆகல அப்படின்னும் போது we'll be ranking the variables. இது 1, இது 2, இது 3, இது 4 அப்படின்னு சொல்லிட்டு ஒரு பேஷண்ட்டுக்குமே அதை ரேங்க் பண்ணுவோம். ஒரு வேரியபிளை ரேங்க் பண்ணுவோம். அந்த வேரியபிளை ரேங்க் பண்ணிட்டு அதுக்குள்ள இருக்க டிஃபரன்ஸ் எடுத்து அதை தான் நம்ம ரோன் வந்து ஸ்பியர்மன் கார்லேஷன் கால்குலேட் பண்றோம். அதான் அந்த ஃபார்முலா ரிலேட் ஆனது. ஓகேவா? ஸோ இங்க எல்லாம் ஆட்டோமேட்டிக்கா ரேங்காவே அவங்க கொடுத்துட்டாங்க. ஸோ இதோட இன்டர்பிரிட்டேஷன் எப்படி இருக்கும்னு நீங்க சொல்லுங்க. ஸோ இதுதான் டேட்டா. ஸோ நம்மளுக்கு ரோ வேல்யூ வந்து 0.85 இருக்கு அண்ட் 0.002 is a p value. So what will be your result? Sorry, it is positively correlated and p value is less than 0.005. So this indicates a strong positive correlation between disease severity and pain level. So pain அதிகமா இருக்க டிசீஸோட சிவியாரிட்டியும் நம்மளுக்கு அதிகமாகும். Am I right? Okay. So next வந்து physical activity level increase ஆக, அதாவது there is any relationship between physical activity level and blood pressure categories. So for an hypertension people இதை எப்படின்னா ரிலேட் பண்ணி சொல்லுங்களேன். physical activityயும் obese சத்தமா சொல்லுங்க. ஸோ உங்களுக்கு இங்க வந்து 4 கேட்டகரி கொடுத்துருக்காங்க பிசிக்கல் ஆக்டிவிட்டி லெவலுக்கு, 5 கேட்டகரி கொடுத்துருக்காங்க பிளட் பிரஷர் கேட்டகரிக்காக. ஸோ இதை எப்படி ரிலேட் பண்ணி சொல்வீங்க? பிளட் பிரஷர் ஆல்சோ இன்க்ரீசஸ் ஃபார் ஹைப்பர்டென்சிவ் பேஷண்ட். இன்க்ரீஸ் ஆகும். சரி, ஓகே. ஸோ இது வந்து பாசிட்டிவ் கார்லேஷனா நெகட்டிவ் கார்லேஷனா? நாங்க டைட்டில் போட்டிருக்கிறதுனால சொல்லாதீங்க, நீங்களே சொல்லுங்க. பாசிட்டிவா? சரி. Okay, I'll change it now if it is. Okay, so this is a data set. I'll give you this slide. இதை ஒர்க் அவுட் பண்ணி பாருங்க, உங்களுக்கு பாசிட்டிவ் வருதா நெகட்டிவ் வருதா அப்படின்னு சொல்லிட்டு. Okay, so your answer will be a strong negative correlation and your p-value is 0.001. Okay, so these are the reference I used for this class, and thank you. So any other doubt? உங்களுக்கு இப்போ டேட்டா செட் வச்சு சொல்லி தருவாங்க, அப்போ உங்களுக்கு டவுட் இருந்தாலும் கேளுங்க, கிளாரிஃபை பண்ணிக்கலாம். ஓகே, thank you.
But correlation talks about only the linear relationship. Okay, right? Is it clear? So what do you mean by linear relationship? What is linear? Yes, it is a straight line. Okay, so it talks about the straight line relationship. There may be some other relationship than the linear relationship. So those are called as curvilinear or non-linear relationship. Can you give me an example for non-linear relationship? Medical data. Related to age. immunity. I'm not that much medical. There's some basic logic thinking. Poranda oru naal. What about the death rate according to age? Infant, it will be high and slowly decreasing to at the age of 5, and then it is straight, and then when age increases, it is increasing. Usually it will call as bathtub curve, right? It will like bathtub, no? So when age, so the 0 to infinity, age it will decreasing up, slowly it will go and it will increase, right? So what is the relationship here? It's something curvilinear, correct? And then hand grip. No, what is hand grip? There will be some measurements to measure the hand grip, the strength of your hand. So what will happen? At the younger age, there won't be, strength will be very low, then slowly increases. Then a certain stage, it will be flattened. Then when age goes, it is decreasing, right? Correct or not? So our correlation talks about only linear relationship. That is very much important. Okay? Okay, right. Thank you. That's what I want to add. So, what is the basic assumption about the nature of variables for which we are going to calculate the correlation? Those two variables should be really related. Something whatever the Nandini told, something like under maybe for younger age and height, age and weight, as we talk about the age and death rate, age and hand grip. So these two variables are naturally related, and we are going to establish the relationship, linear relationship. Okay. Some other thing also, as I told yesterday, if you give something in the computer, it will give some perfect correlation. Okay. So the correlation is 0.9 or correlation is minus 0.9. But it is our duty to give the proper variable. Something like, no, there is for last 10 years wheat production in the Punjab, and the last 10 years total platform tickets sold in the Chennai railway station. So if you put the correlation, the computer will give the correlation is maybe 0.9. So can we infer that if the platform tickets are sold higher, the wheat production will be larger? So this is called spurious correlation. Okay. If the variables for which we are going to calculate correlation have no natural relationship, then it is called a spurious correlation. Okay. So you should be careful as a researcher. If you want to calculate a correlation for two variables, it should be naturally related. Okay. So SPSS will give whatever you give, it will give the result. Okay. It's a sincere, obedient idiot box. Okay. Yes, sir. No. There is no separate test. There are some methods are there to calculate the relationship. Okay. So that is curve fitting. There is a separate thing. Okay. Right. Okay. Thank you. Can we go for the hands-on training? Okay, right? So what do you mean by odds ratio? Any idea? What is odd? What is Kohli? Odds ratio. What is ratio? What is an odd? ODD. Exposure outcome. I am talking about basic thing. What is an odd? Huh? Any idea? ஸோ எல்லாத்தையும் யோசிக்க வச்சுட்டேன் இல்லையா? Okay. So in this session we are going to learn about what is odds ratio, what is relative risk, what is a risk difference. Okay. Okay. Basically, in our medical research, most of our outcome variable, right? Variable of interest or primary outcome variable. What do you mean by primary outcome variable? Yes. So simple, common sense. Think. Okay. So in your research, what is your primary outcome variable? Suppose you are having குழந்தை மருத்துவம், right? So குழந்தை மருத்துவத்தில் வந்து ஒரு காமன் டிசீஸ் வந்து என்ன சொல்லுங்க? சொல்லுங்க, குழந்தை மருத்துவம் யாராரு கை தூக்குங்க. ஓகே, ஒரு காமன் டிசீஸ் என்ன குழந்தைங்களுக்கு? ரெஸ்பிரேட்டரி டிசீஸ். ஓகே, நீங்க வந்து அவங்களுக்கு வந்து நீங்க ஒரு ட்ரக் கொடுக்குறீங்க. ஓகே, அதுல வந்து அந்த ரெஸ்பிரேட்டரி டிசீஸ் கியூர் ஆகுதா இல்லையான்னு வந்து பார்க்கணும். அப்போ உங்களோட பிரைமரி அவுட்கம், பிரைமரி இன்ட்ரெஸ்ட் வந்து என்னவா இருக்கும்? சிம்டம்ஸ் குறையணும். அல்டிமேட்டா என்ன எண்ட் பாயிண்ட் எப்படி சொல்லுவீங்க? ரெஸ்பிரேட்டரி டிசீஸ் இருக்கா இல்லையான்னு சொல்லுவீங்க இல்லையா? கியூர்ட் ஆர் நாட் கியூர்டு. ஸோ தட் இஸ் யுவர் பிரைமரி அவுட்கம். பட் வந்து நீங்க சிம்டம்ஸ் குறைஞ்சதா இல்லையாங்கிறது வந்து செகண்டரி. தேர் மே பி 3 or 4 more symptoms may be there. That may be subsidized or not, may be secondary outcome. Okay, primary outcome வந்து as per case definition, whether the respiratory disease are cured or not. Correct? Similarly, suppose another maybe not only children, adolescents, it may be the anemia. Correct? So anemia is the more prevalent among children, especially the children's based on metro cities, right? So what would be your primary outcome? So if you are giving some iron supplementation or some other medicines, okay, at the end of the day, what will be your primary outcome? So whether there is an increase in hemoglobin or not. So the all other weight gain or maybe whatever the some blood parameter increase or decrease, that will become your secondary outcome. Okay. So the primary outcome based on your research question will be only one parameter. Correct. So that one parameter. So based on that parameter only you have to calculate the sample size also. Okay. So keep it in your mind. So the sample size, analysis plan, study design, sampling technique, everything should be based on your primary outcome. Okay. So that is called primary outcome. So in medical research, most of our primary outcome will be on dichotomous or binary. Okay. So whether cured or not, survived, death. Okay. So basically on symptoms developed or not. Now symptoms means here not symptoms, it may be you can say after giving a drug there may be any side effects developed or not. Not symptoms, actually it is side effects. Survived or died. So outcomes with only 2 options are called binary outcomes. Value 1 for event of interest and 0 for options of our event. Okay. So suppose if it is in case of hemoglobin increased 1, hemoglobin at same level or decreased will be 0. Okay. Cured 1, not cured 0. Survived 1, death 0. It is based on your objective. Okay. Suppose in the survival status you want to know reasons for death, then what would be your event of interest? Survived or death? Yes, absolutely right. So if your interest is event of death, you want to know what are all the reasons for death, then event of interest will be death will be denoted as 1 and survival will be denoted as 0. Similarly, when what is in the case of cement? So if you want to know what is the reasons for failure, the failure will be 1 and success will be 0. Okay, right? Is it clear? Now, okay. Now you know what is about objective and other things. What is cohort study? Any idea? Do you know what are all the study designs? Major cross-sectional study, cohort study, case control study, right? So what is a cohort study? One person. இப்போ சொல்லுங்க அப்பா, கூட்டத்துல கோவிந்தா போட்டீங்க. ஓகே, எங்க மைக்கு எங்க இருக்கு? சொல்லுங்க நீங்களே சொல்லுங்க. What is cohort study?
Prospective, retrospective.
அது type of cohort study. I am asking what is cohort study?
Group of people வந்து ஒரு பர்టిక్యులர் டைம்ல வந்து அப்சர்வ் பண்ணனும். சரி, ஒண்ணு இப்போ எக்ஸ்போஷர் இருக்கு அப்படினா அது எதனால வந்துச்சுன்னு சொல்லி ரெட்ரோஸ்பெக்டிவா பாப்போம். இல்ல
cohort studyனா என்னன்னு டிஃபைன் பண்ணுங்க. இவங்க சொல்றது கரெக்ட்டா? எங்கேயோ சுத்திட்டு வர்றாங்கல்ல, சாப்பிடுங்க இப்படி சாப்பிடணும், இப்படி போய் இப்படி வந்து சொல்லக்கூடாது. சொல்லுங்க, cohort studyனா என்ன? சிம்பிள் லேமன்ஸ் லாங்குவேஜ். கொடுங்க, மைக்கு கொடுங்க, தப்பிச்சுக்கலாம் நீங்க. கொடுங்க, யாரு சொன்னது? கொடுங்க. இல்லையா ஃபன் சொல்லுங்க.
Talks about exposure and outcomes. Risk factor, deals with the risk factor.
Okay. அப்புறம்
So, for a long time observation study to do exposure and outcome relation பார்க்கிறது cohort study. இல்லையா?
ஓகே, கரெக்ட். அவங்க சொல்றது கரெக்ட்டா? ஆல்மோஸ்ட் கொஞ்சம் க்ளோஸரா வந்துட்டாங்க இல்லையா? cohort studyனா நம்ம என்ன பண்றோம்? ஃபர்ஸ்ட் வந்து டிசீஸ் ஃப்ரீ பீப்புளா எடுத்துக்கிறோம். அவங்கள ரெண்டு குரூப்பா பிரிக்கிறோம். ஒன்னு வந்து எக்ஸ்போசர் வித் எக்ஸ்போசர், வித்தவுட் எக்ஸ்போசர். பட் ஆல் ஆஃப் them are disease free and clearly following up them, observing them for an existence of event of interest. So we can call it as incidence of a disease or incidence of our event of interest. Okay, this is called cohort study. ஒத்துக்கிறீங்களா? ஓகே, உங்க தலையில கையை வச்சுட்டாங்க. கரெக்டாங்க மேடம்? கரெக்டுங்களா? cohort study தெரியல. ஓகே, நீங்க எங்கேயோ இருக்கீங்க. ஓகே, this is called cohort study. Okay, is it clear? Yes. ஆமா, be here. cohort study பத்தி பேசல, அடுத்து வர்றேன். உங்களோட டவுட்டுக்கு அடுத்து வர்றேன். 2-3 ஸ்லைடு கழிச்சு உங்களோட டவுட்டுக்கு ஆன்சர் இருக்கு. ஓகேங்களா? So uses two group of subjects, those are free of from disease, and we can classify it into exposed and non-exposed, seeking to determine whether an exposure affects the likelihood of a person will get the disease. நம்ம இங்க அவரோட மெயின் இன்ட்ரெஸ்ட் என்னன்னு பாத்தீங்கன்னா, உங்களுக்கு நிறைய cohort study இருக்கு. பெர்மிங்ஹாம் cohort studyங்கிறது ஒரு ஃபேமஸ் ஸ்டடி. ஓகே, நீங்க லிட்டர் இது வந்து கூகுள்ல சர்ச் பண்ணுங்க. ஓகே, அங்க வந்து என்ன பண்றோம்னா, we will take a group of people free of disease and classify them into those who are exposed and unexposed. So first we are all cancer free people, maybe we can restrict with the lung cancer, and we are classifying them into smoker and non-smoker. What is our exposure here? Smoking. All are cancer free. Okay, so following them for 10 years. At the end of 10 years, among the exposed, that means among the smokers, how many of them got cancer, and among the non-smokers, how many of them got lung cancer? Our event of interest is only lung cancer, and the exposure is smoking. Is it clear? And then at the end of the 10th year, we are going to calculate the, as he said, Dr. unga name enna? Harini. Dr. Harini சொன்ன மாதிரி, what is the relationship of or association between smoking and lung cancer? This is authenticated. ஏன்னு கேட்டீங்கன்னா, first all of them were cancerous free. ஓகே, யாருக்குமே கேன்சர் கிடையாது. ஆஃப்டர் 10 இயர்ஸ் ஸ்மோக்கிங் பண்ணவங்க வந்து 100 பேர் இருக்காங்க. நான் ஸ்மோக்கர்ஸ்ல வந்து ஒரு 10 பேர் தான் cancer, lung cancer develop ஆயிருக்குன்னா, so that 100 may be due to smoking. Okay, is it clear? Right. That is called cohort study. So this is the pictorial representation of cohort study. We have some, so here, if you look at this, so here this is fixed. What is fixed? The exposed and unexposed is fixed. Okay, this is the timeline, onset of the study. We are going to start the study here and we are following up and looking for the disease incidents. Okay, looking for the disease incidents. Maybe after the end of the 10th year, some of them become deceased in the exposed group, maybe 4%, and healthy will be 2%. And in the unexposed group, deceased only 2% and healthy will be 4%. Is it clear? Okay, this is the pictorial representation for cohort study. Okay, right. What is relative? What is risk? What is your risk? It's a probability, right? Okay, it's a probability. Okay, நம்ம exam எழுதிட்டு பண்ணோனே what is the risk for pass? Be positive, right? What is the chance for pass? Okay, so நான் 10 கொஸ்டினுக்கு 8 கொஸ்டின் கரெக்டா எழுதி இருக்கேன், 80% chance. 10 கொஸ்டின்ல 4 கொஸ்டின் தான் எழுதி இருக்கேன், still 50 பக்கம் எழுதி இருக்கேன், பேஜுக்கு ஒரு மார்க் போட்டா கூட, but there is a 50% chance இல்லையா? So risk is nothing but the probability. Among the exposed, how many of them experienced? Okay, denominator வந்து exposed group and numerator how many of them experienced. Okay, probability யார் யாருக்கெல்லாம் இருக்கு, அதுல எத்தனை பேருக்கு வந்து அந்த ஈவென்ட் நடந்திருக்கு. So that is called a risk. Here risk is, the risk of exposed group is nothing but A by A plus B. So here you should know that what is fixed. What is fixed here? So here total A plus B is fixed and C plus D is fixed. So at the end of the study we know what is A plus B and C plus D. At the end of the study, at the earlier beginning we know A plus B, C plus D, right? That is fixed. And only at the end of the study we should know what is A, what is C and what is B and what is D. So this, the A, C, B, D will be classified at the end of the study, right? So here fixed number is exposed and unexposed, and we are looking for the incidence of disease. So the risk for exposed group is A by A plus B, and because being it is disease incidence, we can say it is an incidence of exposed group. Am I correct? Are you able to follow it? Okay, similarly, what is the risk of unexposed group? So it is nothing but C, among C plus D, C have got the disease. So incidence of disease in unexposed is C by C plus D. The ratio of 2 risk is called risk ratio. Is it clear? Do you have any doubt? Okay, is it clear? Okay, now what is a relative risk? Risk ratio. Both are interchangeably coined. So relative risk and risk ratio are similar. Most of the persons are called as relative risk and some of them called a risk ratio. Okay. Now here, among the smokers of tobacco, our exposure is smoking tobacco. Sorry, exposure is smoking tobacco and oral cancer. Sorry, smokeless tobacco. Smokeless tobacco is either it may be a chewing or snuffing, right? So among the smokeless tobacco users, how many of that oral cancer after maybe 15 years or 10 years of usage? So first how many users are there? 2,000 users are there and 8,000 non-users are there. So we are, those 10,000 population, we are following them for a 10 years of period. At the end of 10 years, we found that 10 out of 2,000 got 100 out of 2,000 got oral cancer and 120 out of 8,000 non-smokers got oral cancer. So what is the risk relative risk here. So what is the risk of developing oral cancer among the users? What is the risk among? What is the risk among users? So, smokeless tobacco users, among tobacco chewers. It is nothing but 100 by 2000 is 1 by 20. It is 5%. 1 by 20 is nothing but 5%. We can say that if there is a 100 smokeless tobacco users, that means 100 tobacco chewers, we can expect at the end of the 10th year, 5 of them may get oral cancer. So what is the risk among non-users? What is the risk among your non-users? 120 divided by 8,000. So 12 by 800. What is it? 0. No, it is 12 by 8. It is 1.5%. Correct? Manakanukku correct? 1.5%. Correct? So, even if you don't chew the tobacco, you have chance of 1.5% of getting oral cancer. So now, what is the extra risk I am having if I use smokeless tobacco? What is the risk of developing a oral cancer? What is the risk? It is 100 by 200 whole divided by 100 divided by 2000 whole divided by 120 divided by 8000. This is equal to 3.3. So how will you interpret this number 3.3, relative risk? How will you interpret this? So interpreting relative risk. So if RR equal to 1, what does it mean? Any idea? Logical thinking. So we are dividing one number divided by the other number. What is 3.3? 3.3 is nothing but 5% divided by 1.5%. Correct? Right? So when it will be equal? Mela 5%, killing 5% na 1. So the risk is same. Nee tobacco chew pannalum seri, chew pannlinalum seri, you are having the equal. So tobacco chewing may not be a risk for oral cancer. So you have to interpret that. Incidence in exposed and unexposed group is same. That means the incidents are, there also 5%, here also 5%. So tobacco chewing may not be a risk factor for oral cancer. So that is how. So exposure is not associated with the disease. Okay, we can say that chewing tobacco does not cause oral cancer. Okay, right. And if it is RR is greater than 1, relative risk is greater than 1, you can say that the incidence in exposed group is higher than the unexposed group. What is the incidence here? Among the exposed, among the chewers it is 5%. Non-chewers it is 1.5%. So we can say that exposure positively associated with the disease. We can say that now based on this answer, example, we can say that chewing tobacco causing or associated with oral cancer. Okay, right. If it is less than 1, incidence is exposed is lower than the unexposed. Suppose in the numerator it may be 1% and the denominator it is 1.5%. What would be your interpretation? Among the exposure the incidence is less, unexposure incidence is high, then the exposure may be a protective factor. Correct? You chew tobacco and you won't get the oral cancer, right? So being doctors we have to smile, right? Okay, this is how you have to interpret. Okay, sometimes if you are giving the difference exposure and exposure, you are changing it, it may change. Okay, so that's why you have to carefully given the exposure and unexposure group. Okay, yes. Okay, so you are correct. Your answer is, your question is very correct. A correlation is called a relationship. whenever we are talking about correlation, we are going to talk about the continuous variable. Okay, so correlation, that is nothing but a linear relationship. It is with respect to only a continuous variables. Okay, so height continuous, weight continuous, hand grip is a continuous, it's a unit of measurement. Death rate is a rate, it's a, may take any value between 0 to 1, maybe percentage. If you multiply by 100, it will be percentage, multiply by 1000, death rate per 1000, 1 lakh, like that. Okay, so those are assumed to be continuous variables. Okay, right? For continuous variables only we are saying about correlation and relationship. Whenever we are coming for a qualitative data, categorical variable, we are saying the word, technical word here, association. Their relationship, here it is association. So whether smoking or chewing tobacco is associated with the oral cancer. Both the variables are our input variable and outcome variable. I mean exposure variable and the outcome variable are categorical. In those situations, we have to use association, and it's literally it's a relationship. Okay, here technically we are calling it as association, there it will be relationship. Okay, right. So we can say that based on the previous example, we can say that the risk of developing oral cancer among smokeless tobacco users is 3.3 times higher than the risk of developing oral cancer among the non-users. When compared to non-user, if you are using a smokeless tobacco, or if you are a smokeless tobacco user, you are having 3.3 times higher chance of developing cancer than the non-chewer. Okay, is it clear? Okay, right. What is the risk difference? What is the risk difference? Risk difference is calculated between the risk among exposed minus risk among unexposed. So simple arithmetic calculation. What is the risk among exposed? It is 5%. Unexposed 1.5%. The risk difference is okay, double equal. So I have to change it. It is 3.5%. Okay, now you know what is cohort study and what measure we are going to calculate in cohort study. What is the measure we are calculating in cohort study? Relative risk. Okay, is it clear? And the risk difference also based on this. Okay, right. Now we will go for the case control study. What is case control study? What is case control study? What is fixed here? What is fixed here? Outcome is fixed. That is presence of disease or absence of disease fixed. So in that, this is my sample. I am going to find a blood sample and whoever anemic cases, non-anemic controls. So here outcome is fixed. And I am separating them into cases, anemic, controls, non-anemic. And I am looking for the dietary pattern. Dietary pattern is nothing but my exposure. Is it clear? So we are going backward. Against the time we are going. In the cohort study, with the time we are going. Okay? In the case control study, we are going backward. Clear? Okay. And among the controls, how many of them are exposed and how many of them are unexposed? And among the cases, how many of them are exposed, how many of them are unexposed? Is it clear? Purinjida liya? Okay. Now, case control study, as we explored, uses two groups of subjects. Subjects selected on the basis of disease status. Two groups, deceased and non-deceased. And then retrospective only, searching backward. We are searching backward for the exposure. Okay. In the cohort study, we are searching for, or we are looking for incidence of disease. Here we are searching for the exposure backward, going backward. Sir? No question answer on that. Okay, right. So seeks to determine whether a person with the disease was more likely to expose to a certain risk. Okay, நம்ம first வந்து disease பண்ணிட்டோம், அவங்களுக்கு வந்து ஒரு எக்ஸ்போசர் இருக்கா இல்லையா. இங்க என்ன பண்றோம், oral cancer வந்து பிரிச்சிடுறோம், oral cancer and non-cancerous. Then we are looking for they are chewing tobacco or not. We are then searching for the exposure. Odds ratio is a measure of strength of association between exposure and outcome. Here we cannot say it is a relative risk. Okay, because as we knew that without exposure also the disease may arise. So that's why we are going for the choice or chance, odds of exposure. So that's why I called what is odds. Okay, so here we are going to say only odds ratio, not the relative risk. So what is odd? What is an odd? Odd is nothing but probability that an event will happen divided by probability that an event will not happen. So P by 1 minus P is the odd. Okay, suppose if your team is, suppose we can take a Indian cricket team against Pakistan in the Champions Trophy, ICC International Champions Trophy, right? So we have failed at ஒரு வாட்டி தான் நம்ம தோத்துருக்கோம் இல்லையா, மீதி எல்லா டைம் ஜெயிச்சிருக்கோம். So what is an odd of winning? Odd of winning equal to 14:1. So 14 times ஜெயிச்சோம்னா there is a chance of losing 1 time. So that is called odd. Have you heard about odd? What is the odd of raining today? Chance. It's nothing but chance. So P by 1 minus P is the odd. Okay, just remember this. Nothing else. And then what is a ratio? What is ratio? What are all the ratio you heard about? Ratio enna? 1 something, right? That is the ratio. So a ratio is a quotient of two numbers, but in the denominator, numerator is not included. Okay, if numerator is included in the denominator, what will happen? It can be a proportion. It will become proportion. Okay, so what are the famous ratio? At birth, what is the sex ratio, right? Male, female at birth. And then number of one doctor, how many nurses are there? For one nurse, how many beds are there? For one teacher, how many students are there? All are some examples for ratios. Do you know that or not? ரொம்ப introduction கொடுக்க தேவையில்லை. Okay. Now, odds ratio. Here what is fixed? Here what is fixed? Column total is fixed, right? Okay. So here A plus C is fixed, right? First we are fixing the deceased and non-deceased. So A plus C and B plus D are fixed. So what is the odd of getting a exposure? What happened? Exposure among the case. Use the application. So it is A by A plus C divided by C by A plus C. What is the probability of occurrence of exposure? What is the probability of occurrence of exposure? A by A plus C. What is the probability of non-occurrence of exposure? C by C plus C. Simple logic. That is the odd. Correct? And what is the, so that is nothing but A by C. Odd that a case was exposed is nothing but A by C. Is it clear? புரியுதா இல்லையா? புரியலன்னா சொல்லுங்க. Will you able to understand this or not? Please. So this is more crucial point. You can calculate the odds ratio in your manually also. இன்னொரு 3 ஸ்லைடு தான் இருக்குங்க மேடம். What is an odd? Odd is nothing but p divided by 1 minus p. Okay. Here, among the total cases, how many total cases we are having? A plus c. How many of them exposed? The probability of exposure is a by a plus c. The probability of unexposed, not happening, c by a plus c. So what is the odd? Probability divided by 1 minus probability, that is nothing by a plus c divided by c by a plus c. So that is nothing but a by c. Similarly, what is the probability of among control who is exposed? B by b plus t. The among the controls they are not exposed is nothing by d by b plus t. So ratio of these two will become odds ratio. So this is nothing but a by c whole divided by b by d. After some mathematical calculation, it will become ad by bc. Okay, is it clear? You able to understand this slide? Okay. So odds ratio during pregnancy and then birth weight. So what is fixed here? The fixed is birth weight. So among there are 187 low birth weight and 187 non-low birth weight. Okay, that means normal weight or maybe LGA. What is LGA? AGA, LGA. Larger to gestational age, appropriate to gestational age. கேள்விப்பட்டிருக்கீங்களா இல்லையா? பீடியாட்ரிக்ஸ், குழந்தை மருத்துவம் எங்க இருக்கீங்க? தெரியுமா தெரியாதா? தெரியும். ஆனா நான் ஏன் உங்களுக்கு பதில் சொல்றேன்னு வந்திருக்கீங்களா? ஆமாவா? ஓகே, ரைட். சோ இட் மே பி எனிதிங். நார்மல் வெயிட்டா இருக்கலாம், இல்லாட்டி above the gestational age இருக்கலாம். AGA, சாரி LGA கிடையாது. LGA வந்து lower to gestational age, low to gestational age, normal to gestational age, above AGA, LGA and then 3 கேட்டகரி வரும். நார்மல், லோ அண்ட் above வரும். மறந்துருச்சு. ஓகே, ரைட். அதெல்லாம் ரொம்ப காலத்துக்கு முன்னாடி படிச்சது. ஓகே, நவ வாட் இஸ் த ஆட் ஆஃப் a low birth weight exposure to anemia? What is the odd of low birth weight exposure to that mother exposure to anemia? 62 divided by 125, A by C, right? And what is the odd of non-low birth weight that mother exposure to anemia? Okay, so what is the odds ratio? 2.01. சொல்லுங்க. ஐயோ, இது பாருங்க, இது புரியுதா? ஏங்க ஏபிசின்னு கொடுத்தா புரியுதுங்கிறீங்க, நம்பர் கொடுத்தா பயப்படுறீங்க. அதனாலதான் டாக்டர்ஸ் எல்லாம் நம்பர் பார்த்து பயப்படுறீங்களா? புரியுதுங்களா? அது சேம் ஃபார்முலா தான் யூஸ் பண்ணிருக்கோம். அது வந்து நீங்க சொன்னதான் 62 divided by 187 divided by 125 divided by 187, that will become. So நான் வந்து ஒரு ஸ்டெப்பை கட் பண்ணிட்டேன், ஸ்லைட்ல இடம் இல்லாதனால. ஓகேயா, ரைட். So it will comes about 2.01. So odds ratio equal to 2.01. How will you interpret this odds ratio? So this is how you have to interpret the odds ratio. Odds ratio equal to 1. What does it mean? Among the cases the exposure is same, and among the cases, among the controls also exposure. So among the disease same exposure, among the healthy same exposure. So we cannot assume that, or we cannot conclude that the exposure may be a cause for disease. So if it is more than one, odds of exposure among the cases are higher than the controls, which means exposure positively associated with the disease, and vice versa if it is less than one. Okay, So mothers who, how to interpret this 2.01, mother who delivered low birth weight babies were 1.01 times more likely to be anemic during pregnancy. Okay, here we cannot say authentically, they are more likely. Here they are say 3.3 times higher chance. Here 2.1 times more likely to be anemic during their pregnancy duration, and than those who have delivered non-low birth weight babies. Is it clear? Okay. Because we knew that if the person is non-anemic person, mother can also deliver low birth babies. Okay, so we cannot assume whether the exposure is correct or not. Similarly, there may be some other exposure which may not be able to collect the data. Because in the prospective study, we know all the factors. Here it may not be. So that's why we are going to for the coin the term odds ratio. It's an odd and it's a probability, and we are more likely to be anemic during their pregnancies. So cohort study is more authenticated for exposure and disease relationship. Here we cannot say that much power. Okay, but there is a thing, but based on this we can conduct a cohort study and we can ascertain the cause and effect relationship. Okay, right? Is it clear? Right? Any doubt? Okay, thank you. It's time for tea. Open the hypertensive data and check the statistics for triglyceride and HDL. Okay, so go to analyze, descriptive statistics, frequencies, I'm going to check HDL and triglyceride statistics, mean, quartiles, standard deviation. Okay. So median will be there. So I don't want quartile. I will go with mean, median, standard deviation. Continue. I don't want to display frequency table. Click OK. Okay. So what about the so there are 3 missing cases in the HDL, and in triglyceride there are 2 missing cases. What is the mean of HDL? What is the mean of HDL? 43.7. What is median? So almost closer, right? So difference of 1.7. And what is the standard deviation? 9.7. So whether it is more than half of the mean or not? No. So we assume that it may follow normal distribution because of large sample. Our sample is 350. Come to the triglyceride. What is the mean value? Median? So whether it is positively skewed or negatively skewed? Based on Kirtiya ma'am's presentation, whether it is positively skewed or negatively skewed? Huh? No, எனக்கு கேட்கல. சொல்லுங்க. நீங்க இது கத்துக்கிறதுக்கு தான் வந்திருக்கீங்க, பயப்படாதீங்க. உட்கார்ந்து சொல்லுங்க. அப்பதான் யாருன்னு தெரியாது.
டீவியேஷன் வந்து லெஃப்ட் சைடு இருக்கா ரைட் சைடு இருக்கான்னு பார்த்து பாசிட்டிவ் நெகட்டிவ்னு சொன்னாங்க.
டீவியேஷனை விட அவங்க அந்த ஒரு படம் போட்டிருந்தாங்க, அதுல மீன் எங்க வரும், மீடியன் எங்க வரும். ஸோ மீனை வந்து மீடியன் பெருசா இருந்தா நெகட்டிவ்லி ஸ்கியூடா, இல்ல வந்து மீடியனோட மீன் பெருசா இருந்தா பாசிட்டிவ்லி, அந்த ஒரு இமேஜ் கொடுத்தாங்க தெரியுங்களா? மீன் மீடியன் மோடு போட்டு ஒரு இது கொடுத்துருந்தாங்க தெரியுமா? அதை பேஸ் பண்ணி வந்து இது எப்படி வரும்னு சொல்ல வர்றேன் உங்களுக்கு.
மீனை விட மீடியன் வந்து கம்மியா இருந்தா லெஃப்ட் சைடு வந்து டீவியேஷன் இருக்கும். அப்ப அது
ஸ்கியூடு டீவியேஷன்ல. ஓகே
டீவியேஷன்.
ஓகே ரைட். சரி. ஓகே, வாட் இஸ் த ஸ்டாண்டர்ட் டீவியேஷன்? And we knew that mean and median are not approximately equal. Correct? There is a huge difference. Right? We knew that either it is totally skewed, either left or right. So you don't bother about the direction of skewness. It is skewed. And what about the standard deviation? It is more than half of the mean value. So we can strongly suspect that it may not be follow normal distribution. So okay, how can you check the normality? Okay, so I want to go analyze non-parametric test, legacy dialogues. So here one sample KS test is available. Okay, so here in the non-parametric test you can have Kolmogorov-Smirnov test, and you want to get the what is that? Triglyceride, right? Okay, and what is the test distribution? You want to compare the normal distribution. Okay, then click OK. So what will happen? So it will give the mean, standard deviation, most extreme differences, absolute, positive, negative, test statistics. And here what is this chi-square, the p-value, sorry, what is the p-value? What is the p-value? It is 0, right? So what is your null hypothesis here? What is your null hypothesis here? காலையில் தாங்க சொன்னேன். ரிஜெக்ஷன் இஸ் செகண்டரி. வாட் இஸ் நல் ஹைபோதசிஸ்? மாப்பிள்ளை பார்க்காமயே ரிஜெக்ட் பண்ணிடுவீங்களா? போட்டோ பார்க்காமயே பார்த்துட்டு தானே ஓகே சொல்லியிருப்பீங்க இல்லையா? நான் கேட்கறது மாப்பிள்ளை யாரு, எப்படி இருக்காரு. So what is your null hypothesis? There is no significant difference in the sample distribution and the normal distribution. Okay, I am comparing with the normal distribution. My sample distribution and the normal distribution are same. Okay, my null hypothesis is sample distribution and normal distribution are same. There is no significant difference in the sample distribution and the normal distribution. Between sample distribution, both are same. And based on p-value, I am going to reject null hypothesis and assume that it is not a normal distribution. My sampling distribution is not a normal distribution. This is based on Kolmogorov-Smirnov test. But if you want to know the Shapiro-Wilks test, there is another procedure. You can get both the tests. Okay, and for each group also. Now, I am going to analyze descriptive statistics here, explore. Okay, and here you want to go to the triglyceride and factor list. If you want to compare between gender, you can put gender also in the factor list. So, here from the variable list, you have to select triglyceride and put it in the dependent list, and in the factor list, if you want to compare triglyceride between gender, you have to put in the factor list. Okay, and then in the plots, okay, in the plots, you have to enable this, tick this normality plots with the test. Okay, you have to put normality plots with the test, continue, and then okay. So it will take longer time. Okay, so it will give all the possible descriptive statistics, nothing, everything positive. You can see here. It's also give the, what is this? What is this? What is this plot? Stem and leaf plot also it will give. Okay, it will give all the outputs. Stem and leaf plot for male, and it is for female, and this QQ plot, it will give all possible things. You don't worry about that. In the left side panel, right? In the left side panel, you can see tests for normality. Will you able to see this? Say yes or no. So you can click this test for normality. It will give you both KS test and Shapiro-Wilks test. Okay. You can use frequencies, and then under frequency, what function you have to select? Frequency, what function? So go to analyze, descriptive statistics, explore, sorry. Under descriptive statistics, you have to click explore, and then you have to put the value. Once click explore, you will get the window, this window. Okay, so what is this test for normality? What is here? It will give for whatever the factor list. Actually, you should do with the factor list, not with the overall. Okay. In male, it may be follow a normal distribution. In female, it may not follow a normal distribution. Even in one group, if it doesn't follow a normal group, normality, then you have to go with the non-parametric test. So it is clear that in the male also and in the female also, it didn't follow a normal distribution. So we have to go for the non-parametric test with respect to triglyceride. Okay, right? Is it clear? Okay. Now, I am going to check the systolic BP also. Analyze, descriptive statistics, explore. So, instead of triglyceride, I am going to be systolic baseline between gender, and also systolic follow-up between gender. Click OK. So it will take time, and then I am going for test of normality. So what is your interpretation here? So I am going to check the normality between males and females of systolic BP at the baseline and at the end line. Okay, right? So what is your interpretation here? Whether the systolic BP at baseline follows normal distribution among gender? No, it doesn't. Okay, but in the systolic BP follow up, as per Kolmogorov-Smirnov test, it follows a normal distribution because your p-value is more than 0.05. So you have to reject here. Here, what is this? So 0.071. So here you have to reject null hypothesis and state that based on Kolmogorov-Smirnov test, BP systolic in male follows a normal distribution, but in Shapiro-Wilk test, it won't. Okay, so basically, systolic BP also didn't follow a normal distribution. Is it clear? Okay, so what are all the variables we have identified which didn't follow a normal distribution? Triglyceride, systolic BP baseline, systolic BP end line. Okay, is it clear? Right. And female, it didn't follow. It is non-normal only because p-value is less than 0.05. It is 0.004, 0.00. It is statistically significant and we have to reject null hypothesis. It means that sample distribution is different from the normal distribution. So null hypothesis, sample distribution and normal distribution are same. Now here we have to reject except on that 0.071. So everywhere it is rejected. So essentially this variable BP systolic base and diastolic systolic follow up at baseline and end line is non-normal. Is it clear? Okay, right. Normality? அதுக்கு நீங்க கொடுக்கணும். Okay, so see here, please listen carefully, analyze descriptive statistics, explore, and then in the plot you have to enable this normality plot with test. So it will be comes under plots. Okay, it comes under the options plots. So the plot, if you click this plot icon, you will get the normality plots with test. Okay, then continue, then click OK, you will get it. Okay, right? Okay. Now it is we have seen that triglyceride also didn't follow a normal distribution with systolic BP at baseline and end line didn't follow a normal distribution. Now, so to compare the triglyceride between gender, can you apply the t-test? Can you apply t-test? What is the parametric test to compare two mean values? What is the parametric test to compare to? Okay, what is the test applicable for to comparison of two mean values? T-test. So what is the assumption there? The variable should follow a normal distribution. We have identified that triglyceride didn't follow a normal distribution. So it is a non-normal distribution. So can we apply t-test? Can we apply? No, we can't because it is not a normal distribution. So we have to go for the equivalent non-parametric test. What is the equivalent non-parametric test? Wilcoxon rank sum test, or otherwise Mann-Whitney U test. You stick with Mann-Whitney U test. Otherwise Wilcoxon signed rank sum test different and Wilcoxon rank sum test is different. Okay, so you stick with Mann-Whitney U test. So if it is independent t-test, equivalent non-parametric is Mann-Whitney U test. In SPSS also it will be denoted by Mann-Whitney U test. It will be mentioned as. Okay, right. So how can we do that? So here, and keep in your mind, have you done any non-parametric test manually? Yes? How many have done manually non-parametric test? Whatever the non-parametric, any test. See, this is how you have to raise your hand. No, it is physically more exercise. No, this is not like that. Okay, right. Very good. அவங்கள பக்கத்துல இருந்து பார்த்தாங்களா? ஓகே, எல்லாரும் பண்ணிருக்கீங்க இல்லையா? ஓகே, சரி, டி டெஸ்ட் மேனுவலா பண்ணீங்களா? ஓகே, ரைட். ரெண்டுக்குள்ள மேஜர் டிஃபரண்ட் என்ன? லாஜிக்கல் திங்கிங், காமன் சென்ஸ். நான் பராமெட்ரிக்ல வந்து எதை யூஸ் பண்ணீங்க? அந்த டெஸ்ட் ஸ்டாட்டிஸ்டிக்ஸ் கால் பண்றதுக்கு என்னத்தை யூஸ் பண்ணீங்க? மீடியனா? என்னத்தை யூஸ் பண்ணி அந்த டெஸ்ட் ஸ்டாட்டிஸ்டிக்ஸ் ஒன்னு கொண்டு வருவீங்களா? அதுக்கு என்னத்தை யூஸ் பண்ணீங்க? rank. So in non-parametric test, in all non-parametric test, you will never use a original value. You will use only ranks, above median, below median. What is the above median rank? What is the below median rank? You are going to use only the ranks. Correct? Whereas in t-test, what you have used? Actual observations, right? Original observations. So that's why whatever value in the original observation that is not used for statistical test statistics calculation in the non-parametric test. That's why it is less powerful test. Okay? Right? If you take rank, you take 90% marks, first rank, 99 marks, first rank, 100 marks, first rank. So whatever the more than 90, it will be treated as the rank 1. Correct? So it is based on the ranks. Okay? So that's why we in all non-parametric tests you will never use the original value. Okay, but in parametric test you are always using the original value. So simple logic, correct? Right. Okay. So now I am going to do a non-parametric test for analyze non-parametric test, legacy dialogues, 2 independent samples. Okay, I am going to use non-parametric under analyze non-parametric test, legacy dialogues, 2 independent samples. Click it. What is the test you are going to compare? You are going to compare triglyceride and also systolic baseline. You can give as many as variable you want, but first we can give with one variable. Okay, and you want to compare between what is the grouping variable? Sorry, what is your grouping variable? What is your grouping variable? Okay, so define groups. Same thing as in the t-test. You have to put the appropriate variable, dependent variable, and you have to define the grouping variable. Continue. And what is the test you are going to do? Mann-Whitney U-test. Okay, and you forget about the other test. Okay, click okay. So what is it will give 2 tables. First table with the ranks and second table with the test statistics. So what is your interpretation? What is your null hypothesis here? What is your null hypothesis? Basically in non-parametric test, what you are going to compare? Either statistic or distribution of samples. படிச்சீங்களா இல்லையா? ஓகே, சரி வேண்டாம் விட்டுருங்க. நல் ஹைபோதேசிஸ் என்ன? I don't want to go into base level. Okay, so நீங்களா வளர்ந்துட்டீங்க. What is your null hypothesis here? Basically you are not going to compare any statistic like in parametric test. In parametric test you can compare mean values, you can compare variances, correct, and you can compare proportions also. But in non-parametric test you are not going to compare the statistic directly. Instead of that, what we are doing, we are ranking the observations and comparing between the groups and doing. Okay, that's what saying the mean, rank, everything. Okay, so what is null hypothesis here? Okay, you learn it. Right? Now, whether you have to reject or accept your null hypothesis. whether the p-value is more than 0.05 or less than 0.05. It is more than 0.5, so we have to accept null hypothesis. Then your conclusion is there is no significant difference in the distribution of triglyceride, right? Triglyceride between males and females. So what we are going to compare is the distribution. The pattern of observation in male and the pattern of observation among female are same. So basically we are going to compare the distribution of actual all observations among male and all observation among female. So here we are going to compare the distribution of values between males and females. Here the distribution of triglycerides between males and the distribution of triglyceride between females. So the distribution of the triglyceride is same among male and female. So here we are not going to compare any mean or proportion, not even median. And if the distribution are same, what is indirectly? The median will be same. Okay? Right? Is it clear? We are not directly comparing median and median 1 minus median 2 divided by the standard error of median. That we are not doing it. But we are based on ranking, we are doing it, and then ultimately we are come to the conclusion the distribution of triglyceride between males and females are same. The distributions are similar. Ultimately we are going to conclude that the medians will be approximately equal. Okay? Right. Yes. Okay, right. Now, right. Instead of males and females, you are treat them as a drug A and drug B. Okay. Now you are giving at baseline all are equal, maybe same triglyceride. So all are considered as the hyperlipidemic high lipids. So after 3 months, you are comparing two drugs, drug A and drug B. So what would be your intention? So the new regimen, one standard regimen, now placebo is not accepted. So we are giving the new regimen, maybe new siddha medicine or composition and the standard siddha composition. So you are giving 100 there, 100 here, and the end of the 3rd month or 6th month, maybe 6 months when the change that is. So at the end of 6th month, you are comparing the triglycerides between the new regimen and the standard regimen. And you are, this is your observations and you are doing the same thing, and this is your p-value. So what is your decision here? The reduction after the effect, the distribution of triglyceride, and after the new regimen, the distribution of new glycerides, distribution of triglyceride are similar in the standard drug and the new regimen. Means that the new regimen is as good as the standard one. It is not better than the standard regimen. No. Distribution you can compare between before and after, and between groups. There are two way. One way is between time points, the other way is between groups. So that will be totally different type of analysis. So that is called as, if it is parametric two-way analysis, in non-parametric I think nothing is there. Okay. So it is again what we are going to do it. Here it is only basically two groups, and we are going to compare the distribution of observations. Okay, is it clear? Right? Now you can do for others. And similarly, we knew that what is the equivalent non-parametric test for paired t-test? Wilcoxon Sine-Ransom test. Okay, can we do that? Okay. Now we knew that systolic BP also didn't follow a normal distribution, but we have before baseline and follow-up value. Okay. Now I am going to analyze non-parametric test, legacy dialogues, two related samples. Okay. Two related samples. Before we are going for two independent samples because males and females are two independent groups. Now I am going to compare the before and after. That means baseline systolic BP and at the end of 5th year systolic BP. So I am going to select 2 related samples. Click it. It is as in the paired t-test. Okay. Now, what are all the values I am going to compare? I am going to compare the systolic BP, baseline, and so I am clicking systolic BP, putting it here, and systolic BP at follow-up. Systolic BP at follow-up. So these are 2 variable, 1, 2 are a paired in nature, paired observations. Okay. Now I am going to use Wilcoxon. Okay. Click OK. So it says as Wilcoxon signed ranks test. Okay. As Dr. Vasna informed, what is when the sign will come? Comparing 2 values. It's a paired observation, right? So Wilcoxon signed rank test. Okay. So this will be the ranks table. What is the rank? And so what is your null hypothesis here? Will you reject or accept? You will reject the null hypothesis. Okay. Then what is your null hypothesis? There is no significant difference in the distribution of BP systolic between baseline and follow-up. But we are going to reject the null hypothesis, and what we are going to say, there is a significant difference in the distribution of systolic BP and baseline, between baseline and end line. So here, have you ever seen that any statistics is displayed here? No statistics, no kind of mean, median, quartiles. It won't be produced in the non-parametric test. But can you do that in your thesis? You have to present some statistics, right? So as per yesterday's presentation, what is the appropriate measure for skewed data? Can you present with mean and standard deviation? No. What is the median and interquartile range? So that won't be displayed here. You have to separately calculate, and along with separate table, you have to incorporate this p-value. Okay. Like in t-test, it displayed mean and standard deviation, and below that, it will give the p-value. Correct? Here it won't be. It will give you the ranks only, because ranks are the statistics used for calculating p-values. Is it clear? Okay, right. Now, I think one more is ANOVA, Kruskal Wallis test. Okay. Now, what I am going to do is, so I am going to classify age into, so transform, compute variable. Okay. This is not I am going to do. I am going to do transform, recode into different variable, reset. So age, now age n, and label is age group. Okay. I am going to change it, and what is old and new value? So I am going to whatever low through, maybe 35, value 1, add, so the range 36 to, I can make it as 50. Okay, I don't know what is the distribution. Okay, I can have 45. This is 2, add, and 46 through 60 as 3, add, and lowest, so 61 and above as 4. Okay. 35, 36 to 45, 50. Okay. Continue. So this is for the illustrative purpose. Okay. Now I am going to my data file. So age group 1 equal to less than or equal to 35 years. Add. So 2 equal to 36 to 45. Add 3 equal to 46 to 60. If you watch carefully, no value are repeated here, no? It is 35, 36, 45, 46 and fourth value is greater than 60 years. That means 60 years, 61 years and, sorry, greater than 60 years. You should careful, no? Okay. Now analyze descriptive statistics, explore, reset. I am going to check the triglyceride between age group and plots, normality plot with this one and continue. So test for normality. What is your interpretation here? Yes, everywhere it is not significant based on Shapiro-Wilks and Case test. Is it clear? Is it clear? Oh, but more than 60 years only we have 2 observations. Okay, we can make it as more than 45 years. Okay, we can make it as 3 groups. Okay, now here on this comes handy, your syntax. So I am going to copy this syntax, copy. Syntax file, Control V. Hey. Output, copy. Okay, now here I am going to change 46 through 46 to highest equal to 3 and then control R, F will be then and in the data we will change this as therefore 45 years. Same thing and I will do. Okay, now clear. Okay, now analyze non-parametric test, legacy dialog, sorry, descriptive statistics, explore, the same thing, click OK. So what is your test of normality? So it is only 3 groups and everywhere it didn't follow a normal distribution. Okay. Now if you want to compare the triglyceride between each group, I mean between age group. So you know that it didn't follow a normal distribution. What is the alternate? Equal and non-parametric? It is Kruskal-Wallis test. Okay, now we have to do a Kruskal-Wallis test. Okay, now okay, so analyze non-parametric test, k independent samples. Now it is not 2, it is more than 2, so I am going for k independent samples. So what is your testing variable? Your testing variable is, what is this? Triglycerides. Okay, where is triglyceride? And what is your grouping variable? Age group. Define range. What is your minimum value? 1, maximum 3. Continue. So here I am going to compare Kruskal-Wallis H test. Okay, click OK. So non-parametric test, Kruskal values, it will give you the mean rank. And what is your assumption? What is your null hypothesis? There is no significant difference in the distribution of triglyceride between different age groups. So, and it is accepted or rejected? Accepted. So, there is no need for the post hoc test. Okay. So, if you have, and if you want to go do the post hoc test, here in this test you won't get the post hoc test. You have to go with this test. Okay. So, you can use this, analyze non-parametric test. Instead of legacy, you can go with independent samples. Now, in the fields, you have to give triglyceride. So, we can go with the systolic BP. Where is systolic baseline? Okay. My group is age group. That's all. Run. So, it will give our lengthy output. So, non-parametric test. What is your null hypothesis here? I am going to compare. What is this? The here I am the distribution of BP systolic is same across the categories of age groups. So, no, you are lucky. If you go through this, it will give you the null hypothesis. Right? Right? What is your null hypothesis here? There is no significant difference in the distribution of systolic BP across various age groups. Right? So, if you go to that, it will give you null hypothesis. You can learn more. Okay? And at the end, what is your p-value? 0. Then what is the decision also it will give? What is the decision? Reject null hypothesis. Okay? Now, what does it mean? At least the distribution of systolic BP is different from one age group other than the rest of the age groups, right? இந்த மூணு குரூப்ல ஏதோ ஒன்னு வந்து மீதி ரெண்டுல இருந்து டிஃபர் ஆயிருக்கு. That you have to do a post hoc test, right? So what is the post hoc test? What is the post hoc test? So it will give all the things. It will give the, if it is non-skewed data, you have to go with the box plot. It will give the box plot. See here. This is the post hoc test. Okay. Pairwise comparison of age groups. Okay. Right? It will give. So if you go to that, this independent samples, it will give the post hoc test. And if you go with the legacy dialogues, it won't give the post hoc test. Okay. No, it is inbuilt. Inbuilt. Significant, it will give a post hoc test. If it is not significant, it won't give the post hoc test. Let us check with the other also. Okay. Now, see here. You have to go with the adjusted significant here, because while doing post hoc test, we have to give some adjust. What is that adjust? The adjust is nothing but your have been adjusted by the Banfroni correction. So here, Banfroni corrected adjusted p-value. The post hoc test is like in the post hoc test, what are all the tests we have seen in one-way ANOVA? Dunn's test, Duke's HST, correct? Do you remember? Tamanas, if it is unequal variance, right? Similarly, here the post hoc test is nothing but Banfroni corrected adjusted p-value. So this is adjusted for Banfroni correction here. This is only one test available in the SPSS. Okay. Right. So, and you have to take the adjusted significance. So, what is the first test? Is there any significant difference between 35 years and 36 and 45 years? The distribution? Yes. P-value is less than 0.05. What about between 35 and 35 years? Less than 35 years and greater than 45 years? Yes. And what about the 35 to 45 years versus more than 45 years? Yes. It means the distribution of systolic BP differs significantly between other age groups. ஒவ்வொரு ஏஜ் குரூப்ல இருக்க டிஸ்ட்ரிபியூஷனும் is significantly differs from the other age group. புரியுதுங்களா? So all the three pairwise, right? Three group இருந்தா எவ்வளவு பேர் வரும்? There are A, B, C, three groups. How many pairs will you get? A versus B, A versus C, B versus C. So three groups, right? If there are four groups, how many pairs? 3, 2, 1. 1 versus all the 3. 2 versus all the 2. Rest 2, correct? And 3 and 4. So 3, 2, 1. எவ்வளவு? 3 plus 2 plus 1 equal to 6. Correct? 4 groups. A versus B, C, D. 3 pairs. Leave it A. B, C, D. How much? 2. Okay? Previous 3, now 2. And what? You leave out A, B, C and D. So this is one pair. So how many pairs? 6 pairs. Okay? Right. So all the pairs will be displayed here. You can go with that. Suppose if you triglyceride, it is almost similar. If you look at this, analyze. Where is non-parametric? Non-parametric independent samples. Instead of systolic, I am going to give, what is that? Triglyceride, right? Triglyceride, age group, run. So what is your decision? Retain null hypothesis. That means accept null hypothesis. If you look at here, there won't be any post hoc test. Okay, if you run it, there won't be any post hoc test. Okay, right? Sir, எப்போ post hoc test வராது? இங்க நான் கேக்குறது நானு. So if you are not interested, please. Okay, right. Now what is we have seen? What is that? Kruskal-Wallis test and Wilcoxon-Saint-Rank test and what is the Mann-Whitney test? Okay, all the tests we have seen. For Friedman test, we didn't have the data. We need at least 3 time points data. Okay, right? So that similarly you have to do it. For Friedman test, I will show the syntax, but we didn't have the data. Analyze non-parametric related sample fields. You have to give the 3 variables, okay? Because 3 time points may be baseline, follow up, and maybe the first month, 2 months, 3 months, like that. Okay, I have it. So file, open, data, XLS, non-parametric, open. Okay. Now here see. So pain score at pre-op, pain score at 2 week, pain score at 1 week, mouth opening. So this will follow a normal distribution, and these 3 will be a 3 time point. So I am going to do analyze non-parametric test related samples in the fields. I am going to give pain score pre-op, pain score 2nd week, pain score 1 month, and click run. Oh, right. So I have to convert this into scale variable, analyze non-parametric related samples, run. Yeah. So what is the here the distribution of pain score pre-op, pain score at 2 week and pain score 1 month are same, null hypothesis, and you have to reject the null hypothesis, and this is the statistics, and this is the pain score distribution frequency, and this is the pairwise comparison. Okay, so it will give for the Friedman also, right? Okay, right. Do you have any doubt in the non-parametric test? So I hope that I have walked through it, na? Never run like yesterday, right? Purinjida illaya? Huh? Will you able to do it? Please do it. So, okay. And இது எப்போ பார்க்கலாங்க மேடம்? The logistic regression, maybe. So, how much time will you take for this? Any idea? Sir, சாப்பிட்டு அப்படியே ஒரு மார்க்கமா இருக்கிறப்ப இதெல்லாம் கேட்கலாமா? என்னன்னு பார்த்தோம்? ஸோ விசர் எக்ஸாக்ட் டெஸ்ட்னு ஒன்று பார்த்தோம் இல்லையா? அப்புறம் ஓகே, என்னென்ன இருக்குன்னு பார்த்துடலாமா? ஓகே, now have you done this two variable? Have you recorded this? Hypertensive baseline, hypertensive follow-up, HDL level and age group and also gender. Okay, now have you remember the first slide we have seen the appropriate test of. So if both are categorical, what are all the appropriate tests to be done? Both are categorical, what are all the appropriate statistical tests to be performed? Any idea? chi-square correct தான். சொல்லுங்க. அடுத்து போட்டோவில் எடுத்துருப்பீங்களா? பார்த்தா கேமரா இருக்கப்பா, அதே நாள் பார்க்கலாமே. எடுத்தீங்களா இல்லையா? ஓகே, so I can show you. Visor exact test, then அப்புறம் so input variables are also categorical, output variable is also categorical. What are all the possible tests can be done? Chi-square, Visor exact test, trend chi-square, kappa, McNamara's and logistic regression. Okay, so you know what is chi-square? Kalila paatho. What is Visor exact? When can you use Visor exact test? என்ன less than 5? Cell value இல்லை expected cell value? சரி பாப்பா, it's expected cell value. If the expected cell value is less than 5 in any one of the cells, we have to go for the Visor exact test. What do you mean by trend chi-square? Any idea about trend chi-square? If the input variable is ordinal and the output variable is dichotomous, then you have to perform a trend chi-square. That means as the age group increases, whether the prevalence of diabetic increasing or not. Okay, as the age group increases, the prevalence of diabetic increases or not. So here what is the input variable? Age group. What is the output variable? Diabetic. Diabetic, yes or no, it's a dichotomous. And input age group more than 3 categories. Okay, and we are going to compare, our interest is whether the age group increases, is there an increasing trend in the prevalence of diabetic. So that is called trend chi-square. And McNamara's, kappa are the, I think, have you heard about kappa and McNamara's? Okay, just now you leave out. And then logistic regression. What do you mean by logistic regression? We have seen odds ratio and relative risk. Okay, is it clear? Okay, now I am going to do a 2x2 table or so called contingency table, right? Now I am going to compare, so analyze descriptive statistics crosstabs. No, this is the program menu for syntagma menu, analyze descriptive statistics and then crosstabs. If you click it, so it is nothing but two-way table also, as we seen in yesterday. Now what is in the row variable? Always row variable it should be exposure or input variable. So row variable here is gender. On my column variable I am going to take HTL level. That means HTL risk. Okay. Now you have to go to statistics. I need chi-square. Continue. So in the statistics part you have to click. So in the statistics you have to click chi-square, and these are all the other statistical work we can perform. So we can perform contingency coefficient, pi and Cramer's V, lambda, uncertainty coefficient, nominal by interval eta, kappa, risk and McNamara's. So all these things, ordinal gamma, Somers D, Kental's Dow B, Kental's Dow C, everything is available, but we are mainly going to use chi-square, sometimes kappa, risk and McNamara in case of kappa and McNamara in case of paired data, and risk for our odds ratio and relative risk. So now I am going to give chi-square. So continue, and because among the gender whether the HDL is varies or not, so my base is gender, so I am clicking cell, and then in that I am going to give the percentages. Okay, click continue, and then click OK. So it will give 3 tables. One is case processing summary, and then cross tabulation, and then p value. Okay, chi-square test p value. So if you look at this, so there is no how many missing values. So gender, I think everything is available, but in HDL level there are 3 missing values. So our test performed only based on 347 cases. If you look at overall total is 347. My base is, oh sorry, I have to give the row percentage. Okay. Analyze, descriptive statistics, cross tabs, so cells, we have to give row. Continue. Okay. Now here among the male, how many of them at risk based on HDL level? Among the male, how many of them at risk? Among the male, how many of them at risk based on HDL level? 51% or 51.4% are at risk based on the HDL level, and among female it is 75%. Okay, so here my base is among male, among female, so gender is my base. That's why within gender the row percentage it counts. Okay, now so in the chi-square test, what are all the tests we are having? These are all the tests we are having. Okay, so what are all the output it has given? It is given Pearson chi-square, continuity correction, likelihood ratio, Fisher exact test, linear by linear association, and number of valid cases. Okay, now okay, so these are the different outputs, different types of chi-squares it will give in the output. So what is Pearson chi-square? That is what we are interested in. Okay, Pearson chi-square. So that is normally called as chi-square test. And next one is continuity correction. What do you mean by continuity correction? Any idea? So this continuity correction was introduced by Yates, Y-A-T-S, Yates, or otherwise it is called as Yates continuity correction. It will give some more strict rejection criteria. That means its p-value is always little bit higher than the Pearson chi-square. So if Pearson chi-square gives p-value is 0.1, it will give 0.12 as the p-value. So it will be higher side of the Pearson chi-square, and it will be has strict rejection criteria. Okay. So we are not almost using continuity correction, or it is always better to use continuity correction. If it is significant in continuity correction, it will be significant in everywhere, and likely to leave out, and Fisher exact test. So when you have to use Fisher exact test, somebody says any expected cell frequency is less than 5, we have to use. So is there any indication that how many cells are less than 5? Any indication here? So there is a, if you go to see the Pearson chi-square 19, there is a superscript A. Here in the superscript 0 cells have the expected cell count less than 5. The minimum expected cell count is 49.95. Do you want to know whether that is correct or not? You can check. Okay. I will show. So this is computed by. Now, what is your interpretation here? So, what is your null hypothesis? What is your null hypothesis? So that is a result. That is a result. Okay. That is our inference. What is null hypothesis? Which one we are going to compare here? The prevalence of risk, okay, based on HDL, okay, between genders. So what would be your? There is no association, okay, here not significant difference. Here there is no association between, so there is no association in the prevalence of risk based on the HDL between male and female. So what is our p-value? It is less than 0.5 or? So we have to reject H0 and infer and conclude that the prevalence of risk based on HDL level is significantly differs between male and female. Okay, is it clear? Okay, and if any, because we have the sample size of 350, less than thing we don't know, so it won't come, right? So if it is less than come, you have to go with the, and always you have to go with the asymptotic significance, and in the case of Visser exact test only, you have to go with exact two-sided significance. Okay, if any cell frequency, if at least one cell is less than 5, you have to go with the Visser's exact two-sided significance. Is it clear? Okay, right. Now, the same thing I want to compare between and then 36 to, sorry, under 35 it is 67%, 36 to 45 it is 65%, and more than 45 years it is 64%. Is there any trend? Is there any trend? Is there any trend? So what happened? What is the trend? Age increases, the HDL risk decreases. Correct? So, in those situations, what is nature of age group? Is it ordinal or not? Age group is ordinal or not in this scenario? It is ordinal. Okay? So, you have to go with the, here, linear by linear association. That is, trend chi-square is nothing but linear by linear association. What is my linear? It is a straight line, right? Linear. So that straight line, whether the age is increases, actually there is a trend in the risk, HDL risk is decreasing. But it looks decreasing, but it is not statistically significant. Okay? Right. Now, have you ever seen that here one column called degrees of freedom? Here 1 degrees of freedom, and here it is 2 degrees of freedom. What is degrees of freedom? That is formula. N R minus 1 into C minus 1 equal to degrees of freedom. That is formula. Formula, memorize it. But without formula, how can you memorize? I mean, remember it. What is degrees of freedom? Any idea? Okay, I can give you one example. Okay, so I am in your account. I am give you 10,000 rupees. The condition is you have to spend this 10,000 rupees within 4 days. Okay, right? So how many days? What is the condition? 10,000 rupees should be spent in 4 days. So for how many days you can freely spend as much as you wish? 4 days. Whoever says 4 days. 1, 2, 3, 4, 5. Oh, illaya. Okay. So, okay. மீதி எல்லாம் 4 நாள் இல்லைன்னு சொல்றீங்க, கரெக்டா? ஏன் சொல்லுங்க சார். 1 லட்சம் கொடுத்தா கூட எங்களுக்கு ஒரு நாள் பத்தாது, அந்த கண்டிஷன் கிடையாது. ஓகே, ஏன்? இல்ல, நீங்க 4 நாள் ஸ்பெண்ட் பண்ணி ஆகணும். 4 நாள் மினிமம், ஒரு 10 ரூபாயினால் 4 நாள் பண்ணி ஆகணும். மேக்ஸிமம் 4 days, மினிமம் 4 days தான். ஆனா எவ்வளவு நாள் நீங்க ஃப்ரீயா ஸ்பெண்ட் பண்ணலாம் நீங்க நினைச்ச அளவுக்கு? 3 days. இல்ல இல்ல இல்ல, அப்படி இல்ல. There is a condition for that. சரி, ஓகே, சொல்லுங்க. ஃபர்ஸ்ட் நாள் எவ்வளவு ஸ்பெண்ட் பண்ணலாம்னு நினைக்கிறீங்க? உங்க விருப்பம், சொல்லுங்க. 2000. செகண்ட் டே 3000. ஓகே, 5000 ஆச்சு. தேர்ட் டே 3000. ஓகே, சோ இது 3 தான் உங்களுக்கு ஃப்ரீடம் இருக்கு. 4வது நாள் என்ன பண்ண முடியும்? மீதி இருக்கிறத பண்ணி ஆகணும். You have no freedom. Okay, how many days you have the freedom? 3 days. The 4th day is restricted. Whatever you spend with the 3 days, that has to be subtracted by 10,000. Then the remaining amount is fixed. You have no freedom over it. Correct? So this is called degrees of freedom. Okay, right. இப்போ வாங்க, எப்படின்னு நான் சொல்றேன். இங்க என்ன இருக்கு? Okay, we can go with this. Analyze descriptive statistics, cross tabs, cell, I don't want row, continue, statistics. Okay, so இங்க வந்து degrees of freedom வந்து 1 இல்லையா? ஆனா என்னென்ன fixed? These totals are fixed. There are within 30 less than 35 years 155, 106, 86, 199, 228, and okay, here I can go with this. Okay, so here what is the degrees of freedom? Here it is 1, correct? In the 2 by 2 table, R minus 1 into C minus 1, 2 minus 1 into 1, 2 minus 1, 1 into 1 equal to 1. Degrees of freedom equal to 1. Okay, how can be it 1? So what is the fixed here? The totals 134, 213, 119, 228 are fixed. There is no change in it. So within the 4 cells, if any one cell is assigned, the remaining are fixed. Okay, you have to select only any one of these cells. If you select it is only 65, the risky category is nothing but 134 minus 65. Here female equal to 119 minus 65 equal to 54. So the others are automatically filled. There is no freedom for all these 3 cells. So that's why this is called degrees of freedom. So the formula is row minus 1 into column minus 1. So that is called degrees of freedom. Okay, is it clear? Okay, right. Yaro ma'am, neenga thana kettinga degrees of freedom. Okay, yeah, right. Now we have seen all the chi-squares. Can we go for the kappa? Sorry, kappa venda. Kappa and McNamara's venda. We can go for the risk assessment, okay? Right, now, what is our thing? So, analyze descriptive statistics, crosstabs. Now, in my row category, I am going to give HTL. And in column, HTN baseline, statistics, chi-square, I am also a risk, continue. In cells, I am going to give column, continue. Okay. Right. Now, so 347. Okay. Can you tell me what type of study is this? Cross-sectional, cohort, or case control? What type of study is it? Cohort. How can you say that it is cohort? So there is a follow-up. Correct? But we are dealing with only baseline data, okay? Not the endline data. Okay? So we are having only baseline. So HTN at baseline, HT level, this is also at baseline. Okay? As such, for the analysis, even though it is a cohort study, for on analysis purpose, it should be considered as the cross-sectional study. Okay? Right. Now, how many of them total hypertensive, how many? How many hypertensions are there? Out of 75, total 75, 347, 75 are hypertensive, right? So, cross-sectional study also considered as a case control study. Different versions of different type of case control study, because we are not following it up. We can check only is there any exposure. We should go backward only, because at the time of cross-sectional, we are going to say that whether he is hypertensive or not. Okay? After that, we are going to have, you have HTL level increased or not, that we are going to ask. So, from the cases, we are searching for the risk. Right? It's a kind of case control study, but unequal sizes of cases and controls. Okay? Now, among the hypertensive, how many of them exposure to risk, HDL risk? Yes. Among the hypertensive, how many of them having? 65%, right? Have the exposure for hypertensive. And among the normal, how many of them exposure for risky? Almost similar. So, can you say that this is a HDL level is a risk factor for hypertensive? Can you say that HDL is a risk factor for hypertensive? So, here Pearson chi-square tests, there is no significant difference. There is no association between HDL level and the hypertensive. And similarly, you can see the odds ratio. So, odds ratio when compared to no risk, it is not at all risky category. Okay, so it will give you the odds ratio when compared to risky category. Oh, it should be ulta. Okay, so the reference category is lost, right? Now here you have to change the reference category as HDL level. Okay. So here it says that when compared to no risk category, a risky HDL level have 1.0 time higher odds of more likely to H. They have the hypertensive, but it is not statistically significant because p value is 0.9 and 7 thing. Okay. So similarly, it will give you the, if it is a cohort study, it will give you when compared to normal, what is the relative risk for having hypertensive, it is 1.005. And when compared to hypertensive, what is the risk for when the hypertension have, it is when compared to normal HDN. Hey. Okay, so it will give the, we have to reverse the thing. All right. So here when compared to no risk, what is the odds of getting hypertensive? It is 0.021. Will you able to understand this or not? For relative risk, you have to give the row and column variable, you have to interchange it. Okay, if it is a cohort study, the exposure in the rows, and please listen, to calculate the odds ratio, whatever you have given is perfectly correct. Okay, what is fixed? What is fixed? Cases and controls are fixed. Okay, cohort study and case control study, whatever given the row variable is exposure and column variable is the outcome for cross sectional and case control study. If it is a cohort study, it should be reversed. Okay, right. So for suppose if it is a cohort study, we have to give like that: analyze, descriptive statistics, cross tabs, okay, and then click OK. So now so for cohort study, you have to reverse the column and row, you have to change. Okay, so for cohort of HDL level, when compared to no risk, the risky category have 1.007 time higher relative risk, 1.007 times higher risk for developing hypertensive. And then compared to, in the case of no risk category, they are having 0.986. If it is less than 1, it is a protective factor. Okay, so it says that no HDL is a protective factor, but it is not statistically significant. So you should be careful in while choosing rows and columns. Okay, correct? And you having the same thing, and then you should not interpret the odds ratio and risk ratio, relative risk. Okay, is it clear? Will you able to understand or not? புரிஞ்சுதா இல்லையா? ஓகே, ஏன்னா இது வந்து அந்த காலம் ரோ வந்து கோஹார்ட் ஸ்டடிக்கு வந்து ஒரு மாதிரி கொடுக்கணும். கோஹார்ட் ஸ்டடிக்கு வந்து எப்படி கொடுக்கணும்னா, your exposures for cohort study, what is fixed? This is fixed, right? Risk and no risk. Exposed and unexposed will be the in the column heading. And then baseline normal hypotension. We are looking for the, searching for the prevalence of the or incidence of the disease. That should be in the our row variable. And then whatever already fixed known will be in the top. So that is for cohort studies. In case of cross-sectional study or case control study, what is fixed? Normal, diseased and not diseased are fixed. So that should be in the column. Whatever fixed, that should be in the column. Whatever we are looking for should be in the row. Is it clear? Whatever fixed, that should be in the column. Whatever we are looking for in the row. Is it clear? So it depends on the, so for cohort study, which one is fixed? Exposure is fixed, right? And for case control study or cohort study, what is fixed? Case control study or cross-sectional study, what is fixed? Diseased, undeceased is, non-diseased is fixed. Okay, so that should be in the column. Accordingly, you have to interpret the odds ratios and chi-square. And apart from this, there is one more function or way to calculate the odds ratio. That is little bit tedious. Please listen here carefully. Analyze regression, binary logistic regression. You can do this way also. Here, analyze regression, binary logistic regression. Here, what is your outcome variable? So, my HDN baseline, this is my primary outcome variable, dependent variable. And it will take as the highest value as the dependent category. So, I have to change once again. Okay, normal HDN, okay, cancel. Okay. So, keep in your mind that, so as far as the Spss is concerned, if you are using the binary logistic regression, your dependent variable, so your disease category should be always have the largest value, it should be 1. Okay, hypertension will be 1. The event of interest will be always 1. Non-interest of event, other event will be 0. Okay, it will be always calculated for the 1. That means highest value. And what is your factor associated with? You want to have HTL level, and this you have to say that the HTL level is a categorical variable. So once you put the HTL level here, you have to go and select categorical. You have to say HTL is a categorical. And what is your reference value? Whether first value is a reference value or second value is a reference value. Here I have said that 2 is the non-risky category. So last, and then I can have change, continue, and also in the option you have to select the confidence interval for your odds ratio. Continue, click OK. So it will give so many tables, case processing summary, dependent variable encoding, categorical variables encoding, beginning block, and then block 1 method, enter. So if in the last table, variable in the equation, okay, you can see HT level 1 equal to, this is your odds ratio. Express now, E of beta will be your odds ratio, and it's your 95% confidence level, and then this is the p-value 0.937. So this is also the another method you can use, and keep in mind that in the chi-square you can do odds ratio for only 2/2 tables. That is 2/2 contingency table. If you have something like age category, you have to go with this procedure. Okay, so I can do with this for another thing. I am going with analysis, regression, binary logistic. Instead of HTL risk, I am going for the age group. And I am going to say that age is a categorical. And what is my first younger age, my reference category, and putting that is a change. So if you look at here, age indicator will become first. And then continue. So options, I need the confidence interval. Click OK. So it will say, and you come to the last. So this is the risk. When compared to, what is your reference category? Younger age group. Compared to younger age group, the middle age group have how much? 8.57 times more likely to have hypertensive. And compared to younger age group, the age group more than 45 years have 16 point. These are the odds ratio, and it's 95% confidence interval, and this is the p-value. So this is how you have to do when the more than two categories. So this is the way you have to do. Okay, is it clear? Will you able to do it? Okay, there are 10 minutes, you can do that. Chi-square test and logistic regression at 3 o'clock. Kritiya will take over the class. Thank you. If you have any doubt, you can ask.
Two variables. Okay, then. So the relationship can be positive or negative. Okay. So in this session, what we will see is what correlation is not telling us, then what is regression, what is linear regression, then what is simple linear regression, and then what do you mean by multiple linear regression, then what are the assumptions that are needed to do this linear regression analysis, then how to do model selection for multiple linear regression, and finally how to present your results in the manuscript. So what will correlation not tell us? So you see, it does not imply causation. So if you have some positive or negative correlation, a strong correlation or somewhat moderate correlation, it does not imply that some variable causes the other variable. Okay, so X does not cause Y when you have correlation. So correlation will not tell you this variable is the reason that the other variable had occurred. Okay, so just because the two variables are correlated does not mean the one causes the other. So that information we cannot get it from correlation. The second thing is we cannot determine the exact nature of the relationship. So it only measures association and not dependence. So for example, on the right side you can see there are two graphs. So ரெண்டு கிராஃபுக்குமே வந்துட்டு R என்றது correlation coefficient காலையில படிச்சிருப்பீங்களா. So R is 0.58 ரெண்டு கிராஃப்க்கும். Okay, which means what? Positive or negative correlation? Positive correlation. Okay, strong or weak correlation? Somewhat strong. Okay, ஏன்னா நம்ம real life situationல you can't see a correlation of 0.9995, but this can be considered to be slightly moderate to strong. Okay, so ஆனா first graph க்கும் second graph க்கும் நிறைய difference இருக்கு இல்லையா? So what is the difference? Slope is the difference. So அந்த angle எப்படி இருக்குன்றது difference. So இது வந்துட்டு நமக்கு correlationல இருந்து நமக்கு தெரியாது. So that is why we'll have to go for regression. And the third point is it does not control for confounders, which means other variables may be influencing the correlation. அதோட example இங்க கொடுத்திருக்கேன் for you to simply understand. So high ice cream sales correlate with more drowning incidents. So என்ன சொல்றாங்கன்னா வந்துட்டு there is more number of ice cream sales, அதே மாதிரி there is more number of drowning incidents. Okay, which means actually there is a correlation, right? But one does not cause the other. Yes, that is true, right? Of course, eating ice cream will not make us drown. But we have another common factor which plays, which is the warm weather. Okay, so these are called confounders, but we will not go in detail. So these are the situations where we will have to be very careful. Okay, when one variable has an influence on both the variables that we are looking at. So what is regression? In simple sense, it just models relationship between variables. Okay, and regression le eppodume we use these two words. One is dependent variable and the other is independent variable. So all the variables in regression are classified either as dependent variable illana independent variable. So hereafter I'll refer to them as DV dependent variable and IV for independent variable. So independent variable na enna, it is an input or it is a driver or a factor that has an impact on the dependent variable. Okay, So this dependent variable can also be called as outcome variable or response variable. So regression will help us to predict the outcome variable based on one or more predictors. So independent variable ki innor peru irukku, predictors. So these are the different words that we will always see in regression context. So what are the various purposes of regression? So first one is simply to describe any relationship between a dependent variable and one or more independent variable. The second one is to estimate. So value of dependent variable can be estimated using observed values of independent variable. And the most important one is prediction. Okay, so prediction, we can predict the outcome variable. Okay, so outcome is dependent variable, and the changes in dependent variable will be based on relationship between the dependent variable and the independent variable. And the last one is controlling. So controlling means here control the effect of one or more independent variable while we are trying to investigate the relationship between one dependent variable and the other independent variable. Okay. So now let's come to linear regression. So there are n number of regressions. Adala linear regression is what we will see now. In linear regression, always the dependent variable is continuous in nature. So data type of dependent variable should be continuous, and independent variable need not be continuous. Okay, so dependent variable continuous irundha, then we say it is linear regression. And also the nature of the curve that we are going to fit. So regression nale vanditu it involves a curve. So on the curve will be a straight line. So that is why we call it linear regression, because it is a straight line. So for example, what we can do using linear regression is we can predict blood pressure based on BMI and age. So blood pressure indradhu independent variable which is continuous, right? And then independent variable inga BMI and age. Good. So the second example is, let's say we want to predict recovery time based on dosage of siddha medication. So which is the dependent variable inga? Recovery time, because that is what we will be able to predict. Nama eppodu dependent variable da predict panavom. Okay, so recovery time is a dependent variable. And what is the independent variable? Dosage of medication. Okay, so if you have to go a little bit detail and see what it is, then we can explain the impact or of changes in the dependent variable, that is recovery time, due to the corresponding changes in the dosage. So that is what regression will be telling us. Or we can predict the value of recovery time based on the observed values of dosages. Okay, so this is what regression does for us. So now let's come to what is simple linear regression. So we saw linear regression means there are two criteria basically that linear regression should satisfy. One thing is dependent variable continuous ah irukano, and then there should be a linear relationship or the curve should be straight line. Okay, fine. So simple linear regression na, here again this is a linear regression where you have only one independent variable. Okay, so models a relationship between a single independent variable and a dependent variable. So let's call variable ku vandu, let's give some notation. Okay, so independent variable let's call it as x and dependent variable y. So we have a regression equation here, so which is y is equal to beta naught plus beta 1 x plus epsilon. So y indrathu we know it is dependent variable, equal to right side is the regression equation that we have. So if you see it, does anyone remember what is the equation for straight line?
y is equal to a plus bx. எங்கேயாவது கேள்விப்பட்டிருக்கீங்களா? Okay, fine. So just understand that there is, ஏதாவது ஒரு லைன் வரைஞ்சிங்கன்னா you can write that in the form of an equation, right? அதுலயும் if you have a straight line, then the equation is y is equal to a plus bx. X inறது x axis, y inறது y axis, okay? So you can find for different values of a and b, you can find different lines. So இங்க நம்ம என்ன பண்ண போறோம் regressionல அப்படின்னா, when you supply the software with your data, அதாவது டேட்டானா both dependent variable and independent variable, if you are going to provide it to SPSS, then that will find out this value of a and b and give. Okay, and இங்க இந்த a b என்னன்னா, a ன்றது தான் beta naught, which is a constant. Beta naught ன்றது we say it as a constant. Okay, and beta 1 ன்றது வந்துட்டு regression coefficient. Okay, so beta 1 is called regression coefficient, or it is also called as slope. So mathematical terms la the slope ன்னு சொல்லுவோம். So இந்த angle இருக்கா, இந்த angle இருக்கா, இந்த angle இருக்கான்ற decide பண்றது இந்த beta 1. That is why it is called as slope. And then at the end you also see one more term, which is epsilon. So epsilon here refers to error term. Okay, so always in statistics, so that's the difference between the mathematical equation and statistical equation. In maths equation you only have y is equal to a plus bx, but in statistics you have plus an error term as always attached to it. Okay, so this is how you have a generic equation. Okay, so inga y is dependent variable and only one x is there, that is only one independent variable. That is why it is called simple linear regression. Okay, and one more thing, linear regression na you should see that the x, okay, will be linearly related to y. So there will not be x square irukadu, x power 3 irukadu. So x should have the power 1. That is when we say it is linearly related. So y is equal to a plus b x square nu pathina, then it will not be a straight line, it will be a curve. Then you will not be able to use linear regression to understand that relationship. Okay, so what is the basic assumption here? First assumption and the most important one is there should be a linear relationship between x and y. So நீங்க காலையில படிச்ச மாதிரி, like you told me, right, correlation is a linear relationship between two variables, not just any relationship. So same way, only if you have linear relationship between an independent variable with the dependent variable, then you can use linear regression. Okay, independent variable ko dependent variable ko linear relationship illa abdina, we cannot use linear regression. Though there can be other relationship, there can be curvy linear relationship irkalam or exponential relationship irkalam, but under situations la we will not be able to use linear regression. And then so we talked a lot about error, right? So adukku innor per enna, we say residuals. So errors are also called as residuals. So residuals வந்துட்டு normally distribute ஆயிருக்கணும். So உங்களுக்கு இப்ப தெரியும் normal distribution என்னன்னு இல்லையா? So இப்போ இந்த ஈக்குவேஷன் வந்துட்டு எப்படி உங்களுக்கு வரும்னா, y and x values உங்க டேட்டா செட்ல இருக்கும். அதை நீங்க SPSS சாஃப்ட்வேருக்கு ப்ரொவைட் பண்ணீங்கன்னா it will calculate beta naught, beta 1 and epsilon and give it to you. Okay, so இந்த epsilon values எடுத்து ஒரு distribution or for example histogram போட்டு பார்த்தீங்கன்னா, then you will know whether it is normally distributed or not. So and the error terms should be normally distributed. So these are the basic two assumptions for linear regression. So again, example, let's say we want to predict lung function based on number of cigarettes smoked. So in the lung function should be measured in a continuous scale. அப்பதான் நம்ம linear regression use பண்ண முடியுங்க. So multiple linear regression, here there's just one small difference. So simple linear regression na only one independent variable. Multiple linear regression na you can use more than one independent variable. Okay, and everything else is same, which means outcome variable, dependent variable continuous ah irukanum, independent variable can be continuous or need not be continuous. So அதோட equation பாத்தீங்கன்னா you have more than one x ல நிறைய independent variable இருக்கும். So you have x1, x2 and so on till xn. So there are n number of independent variables here. So ஒரு independent variable க்கும் we will have a regression coefficient. Okay, that is what is beta 1 is a regression coefficient for x1. Beta 2 is the regression coefficient for x2 and so on. So ஒரு independent variable க்கும் we will have a regression coefficient. So what are the advantages? It's that here you will be able to adjust for other variables. Okay, mostly in epidemiological sense we call it as confounders. And then it is more accurate and it gives more accurate predictions than simple regression, because நம்ம என்ன சொல்றோம்னா ஒரு வேரியபிள் இன்னொரு வேரியபிளை எவ்வளவு இம்பாக்ட் பண்ணுதுன்னு நம்ம சொல்றோம் இல்லையா, that's what we saw. But நேச்சர்ல it's not that only one single variable will be impacting another variable. Multiple factors இருக்கும். So always you will get better prediction when you use multiple linear regression. So here for example we want to predict diabetes risk based on 3 variables, independent variables. One age, BMI and physical activity. So again the diabetes risk should be measured on a continuous scale. So this can be done in multiple linear regression. So what are the assumptions in linear regression? So first linearity. Okay, now linearity ன்னு சொல்லிட்டு இருக்கேன். So exactly in the linearity na என்னன்னா every independent variable should be linearly related to your dependent variable. That is what I mean by linearity here. Okay, so which means basic first regression start பண்றதுக்கு முன்னாடி you will have to make scatter plot or a simple correlation check and see. எதுக்கு ஒரு independent variable க்கும் with the dependent variable you will have to make scatter plots and see. Okay, to see if that relationship is linear or not. அந்த ரிலேஷன்ஷிப் லீனியரா இருந்தா மட்டும்தான், லீனியர்னா இட் ஷுட் லை இன் அ ஸ்ட்ரெயிட் லைன். ஓகே, ஸோ ஒரு ஸ்ட்ரெயிட் லைன்ல எல்லா பாயிண்ட்ஸுமே லை ஆகுற மாதிரி இருந்ததுன்னா தென் வி சே தட் இஸ் அ லீனியர் ரிலேஷன்ஷிப். அப்போதான் அந்த வேரியபிள்ஸை நம்மளோட ரிக்ரெஷனுக்கு நம்ம யூஸ் பண்ண முடியும். ஐ மீன் லீனியர் ரிக்ரெஷனுக்கு நம்ம யூஸ் பண்ண முடியும். ஓகே, the second one is no multicollinearity. So says that independent variables should not be highly correlated amongst them. Okay, this is very important when you are doing multiple linear regression. So என்ன ஆகும்னா எப்போதுமே we are talking about correlation between independent variable and dependent variable. Okay, but sometimes you will see that certain independent variables are correlated with other independent variables. Okay, for example உங்களோட independent variable listல height and weight இருக்கு. ஓகேவா, ரெண்டு independent variables இருக்குன்னு வச்சுக்கோங்களேன். Other independent variables are also there, but let's say you have 2 independent variables which is height and weight. Okay, so height increase ஆக அந்த personோட weight increase ஆகுமா இல்லையா, generally speaking. So height-க்கும் weight-க்கும் correlation இருக்கா இல்லையா? It is there, right? So here 2 independent variables are correlated. Okay, ஆனா for linear regression that should not be the case. ரெண்டு independent variables correlate ஆயிருக்க கூடாது. ஓகே, அப்படி ஆயிருந்தது அப்படின்னா அந்த கண்டிஷன் பேர் தான் multicollinearity நம்ம சொல்றோம். So there should not be multicollinearity when we are doing linear regression. So ஒரு independent variableக்கும் இன்னொரு independent variableக்கும் correlation இருக்கக்கூடாது. ஓகே, இது நம்ம எப்படி கண்டுபிடிக்கலாம் linear regression அப்படின்னா when we are running it in the software analysisல we get one number called as variance inflation factor, VIF அப்படின்னு மென்ஷன் ஆயிருக்கும். அந்த வேல்யூ வந்துட்டு 10க்கு கீழே இருந்தா then we can say we are okay safe, multicollinearity problem இல்ல. If it is greater than 10 then there is a serious problem of multicollinearity. Okay, so the third assumption is independence of errors. So observations should not be dependent on each other. Okay, அதாவது ஒரு observation இன்னொரு observation independent இருக்கணும். Okay, if you are measuring some information it should not be of bad nature. Okay, so that is what is independence of error. I mean, observations independent are the most of the situation your errors will also be independent. Okay, so how to test this? Again, you can run plots to see this, but you can also do a statistical test. And the test ku peru Durbin-Watson test. So if you are doing this test, it will tell you whether there is autocorrelation or not. Autocorrelation should not be there. Okay, that is the assumption. Then final assumption is normality of residuals. So this is what we saw in simple linear regression as well. So adhe mari after we get the errors, ada plot பண்ணும்போது it should be normally distributed. So that is what is the last assumption. Okay, so till this, is it clear? Fine. So I told you in multiple linear regression நமக்கு more than one independent variable இருக்கும் இல்லையா? So எல்லா வேரியபிளும் நம்ம இன்க்ளூட் பண்ணணுமா? ஏன்னா என்னோட அனாலிசிஸ்ல லெட்ஸ் சே நான் 20 இண்டிபெண்டன்ட் வேரியபிள்ஸ் கலெக்ட் பண்ணியிருக்கேன். எல்லா வேரியபிளும் உள்ள போடணுமா, இல்ல நான் சிலதை மட்டும் செலக்ட் பண்ணலாமா, எப்படி செலக்ட் பண்ணணும்? So that is what we'll see here, which is called as model selection in multiple linear regression. Okay, so before going to this, first and foremost thing என்னன்னா, என்கிட்ட எல்லா இன்ஃபர்மேஷனும் இருக்கு, so I will put every variable that I have inside the regression model. அப்படின்னா that's not right. So first step is you will have to go and do a literature search to see எந்தெந்த independent variablesலாம் வந்துட்டு add பண்ணா it is meaningful. Basically நம்ம என்ன பார்க்குறோம் இங்க, relationship between the dependent variable and independent variable. So independent variable should be related to their dependent variable. So அதுக்கு ஏதாவது meaningful correlation இருக்கா, meaningful impact இருக்கான்னு first you will have to go and search the literature. அதுக்கப்புறம் only for those you will be able to put it in the model. அப்பதான் it is meaningful, because நீங்க என்னதான் சாஃப்ட்வேர்ல போட்டாலும் anyway it's going to give you a number. So it's not correct to interpret anything and everything. So you will have to carefully choose which are the independent variables. So first step is you will have to see if it has any clinical relevance or meaning. Independent variable. So on the correlation example காமிக்கும்போது there was no meaningful relationship at all. So ரெண்டுத்துக்கும் வந்து correlation ஹையா இருந்தது, but ஆனா there was no meaning. So அந்த மாதிரி even in your research you should have a meaningful list of independent variables or dependent variable. Okay, so after you have selected the relevant variables, then there are several methods to do this model selection. Okay, so first is called as stepwise regression. So stepwise regression na it adds or removes the predictors. Predictors means dependent variable or independent variable? Independent variable. Okay, they are the ones which are predicting the dependent variable, so they are called as predictors. So adds or removes predictors based on their statistical significance. So இந்த ஸ்டெப் என்ன பண்ணணும்னா, ஃபர்ஸ்ட் நீங்க வந்து ஒரு மாடல் regression model run பண்ணணும் with one independent variable, and then you will note down what is the statistical significance. Statistical significance means p value. Okay, அதுக்கப்புறம் திருப்பி you will add another variable, note down the p value. So இந்த மாதிரி நீங்க multiple times பண்ணும்போது then you will know which is the better fit. Okay, அதை யூஸ் பண்ணீங்கன்னா it's called as stepwise regression. The second one is backward elimination. So here we start with all variables and then remove the least significant step by step. So எல்லா வேரியபிள்ஸும் ஃபர்ஸ்ட் என்னென்ன வேரியபிள்ஸ்லாம் independent variables you have thought of, அதெல்லாமே you will put it in the model. Okay, run the regression, then you will note down the significance value. அதுக்கப்புறம் ஒரு வேரியபிள் ரிமூவ் பண்ணி பார்த்தா எப்படி இருக்கு significance, improve ஆயிருக்கா இல்லையா, அந்த மாதிரி you will be removing the variables by checking the significance. Then forward selection is the opposite of backward elimination. So you will start with one independent variable, you will run regression, அதுக்கப்புறம் அதோட significance note பண்ணிட்டு then you will run the second regression where you will have two variables, and then like that you will keep adding and you will remove it if it is not adding any meaning to your regression. So significance illa abdina, you will not have it in your model. So this is how you do forward selection. And in doing all this multiple linear regression, there is one important characteristic, which is R square. So this is called as coefficient of determination. So this is one important value which we always look at. And there is another value which is called as adjusted R square, which is very important in multiple linear regression. Okay, so this helps to determine how well our model fits the data. So goodness of fit, நம்மளோட model fit எவ்வளோ குட்டா இருக்கு அப்படின்றது இந்த R square value will tell. So higher the R square, better the fit. Okay, and this is of course it ranges between 0 and 1. So adjusted R square என்றது என்னன்னா, it is an adjusted version of R square. Okay, so what happens in multiple regression is, நீங்க ஒரு வேரியபிள் ஆட் பண்ண I mean independent variable ஆட் பண்ண your R square value will obviously increase. அதுக்குன்னு it doesn't mean that actually the model is fit. Okay, only if you add relevant variables, the model is going to be a better fit. So adukku da there is an adjustment factor. Okay, that is what is called as adjusted R square. So whenever you are doing simple linear regression, you can use R square. Model fit irka illaya appdin paakradhukku R square use pannalam. When you are doing multiple linear regression, you should look at adjusted R square, not the usual R square. Okay. Okay, so we'll just look at an example here, which we will be using for hands-on as well. So here, what is this plot? Scatter plot, right? Because you have a relationship between two continuous variables, right? One variable is your dependent variable and the other is independent variable. Can you tell me which is the dependent variable here? First, ரெண்டு வேரியபிள் என்ன இங்க இந்த ஸ்கேட்டர் பிளாட்ல? FEV and height. Okay, so இதுல dependent variable எது? FEV, and the independent variable height. Why are you telling that FEV is dependent variable? Yeah, FEV depends on height and your height does not depend on FEV. So that is what I mean. You will have to understand what is the clinical importance. So based on that, you will have to choose your dependent variable carefully. Okay, so dependent variable is FEV and then height is your independent variable. So is it simple linear regression or multiple linear regression? Okay, first linear regression. லீனியர் ரெக்ரெஷனா இல்லையான்னு எப்படி சொல்லுவீங்க? பேக் சைட் என்ன பண்றீங்க எல்லாரும்? Yes, I want answers from the back side. Is this linear regression? Why? Now, I'm not going to move forward unless I get some answer from the last bench. If you want me to explain, I can explain it again. Okay, இங்க இருக்கிறது linear regression இல்லையா? What do you mean by linear regression? Straight lineல இருக்கணும். Okay, so straight lineல இங்க இருக்க அந்த relationship, almost all the points sort of lie in a straight line. Okay, good. So therefore it is linear. Fine. So next, where enna irukano? Dependent variable continuous la irukano. So inge dependent variable enna sonnom? FEV. FE என்றது continuous ah measure பண்ணிருக்கோமா இல்லையா இங்க? Continuous தான், right? So that is how we know that okay, it is linear regression. Next question, simple linear regression இல்ல multiple linear regression? Why not multiple? ஒரே ஒரு independent variable, that is height. அதுதான் இருக்கு. So therefore it is simple linear regression. Okay. So just by looking at this, you can't say இங்க regression இருக்கா இல்லையான்னு. இந்த plot வந்துட்டு வெறும் it's a scatter plot. Okay. With a line. Fine. So here, let's say this line is the regression line that we fitted. Okay. And the regression line, you remember y is equal to beta naught plus beta 1 x. நம்ம போட்டிருந்தோம்ல. So அதுதான் இங்க இருக்கு. FEV, that is our dependent variable y. Again, whenever you are doing regression, it's very important you will have to note down the units in which you are measuring your variables. Okay. So FEV is measured in liters in the example, let's assume. And then your beta naught value என்னன்னு சொல்ல முடியுமா இங்க இருந்து? Beta naught from this equation. Very good. Minus 5.433 is your beta naught. It's also called as beta naught ke innoru per constant. Okay, fine. So what is independent variable? Height. So in what units is it measured? Inches. Okay. So what is the regression coefficient for height? 0.132. Okay. So இப்படிதான் நம்ம அந்த regression equation எழுதணும். Okay. So these two numbers you will get it from the software. Fine. So now, how do you interpret 0.132? So 0.132 it's a beta coefficient that we got. Okay. So இது என்ன சொல்லுதுன்னா, for every unit change in your independent variable, what will be the change in your dependent variable? That is what is the interpretation for this beta 1. Okay. So here in the example, for every unit increase in height, unit enna inga inches. So for every inch increase in the height of the person, 1.32 times your FEV value in liters will be increased. Why increase? Because it is plus here, right? Plus 0.132. Fine. If it is minus 0.132, then for every 1 inch increase in the height, your FEV value is going to decrease by 0.132. So this is the interpretation of beta coefficient. Okay. Now, so after we do the regression, we will have to see whether it is a good fit or not. And the regression line வந்துட்டு ப்ராப்பரா நம்ம டேட்டாக்கு ஃபிட் ஆச்சா இல்லையா அப்படின்றதா we say in terms of whether it is a good fit or not. So how will you determine good fit ஆ இல்லையான்றது? R square. Okay, it is not R, it is R square. So it is called as coefficient of determination. So let's say here the coefficient of determination is 0.754. Okay. So இதோட interpretation என்ன அப்படின்னா, 75.4% of the variation in the dependent variable, which is FEV, is explained by the variation in the independent variable, that is height. So always this value we want it to be as high as possible. So maximum amount of variability in your dependent variable should be explained by your regression. Okay. So inge this 0.754 என்றது 75.4% of the variability in the dependent variable is explained by the variability in your independent variable. Okay. Or if it is more than one independent variable, then put together with all the independent variables, how much variability is being explained. Okay. That is what is R square. So the remaining 24.6% could not be explained. That is because there are other factors which we have not included. That is fine. Okay. We cannot always achieve 100%. And in general sense, if you see a R square value of 0.754, that is very good. Actually, you will not be able to get very high value of r square. If you see very high values of r square, then it's obvious that you are making some error mostly. Okay, fine. So finally, let's come to how we present our results in a manuscript. So this I have taken a screenshot from a manuscript, where first thing you can do is put the scatter plot as one of your figures. So here you will have to definitely mention what is your y-axis and what is your x-axis, and mostly please retain your dependent variable in the y-axis and your independent variable in the x-axis. Okay, and you should be having dots, that is the data, that is the scatter plot which you have, and then you should have your regression line, and it's good to also mention the equation in the graph. Okay, so you will have a overall idea of what regression it is. So here you see it is a simple linear regression. Why? Because there is only one x, that is hand grip strength, and then let's say plot A is for males and plot B is for females. Okay, so can you now interpret what is 0.0765? Interpretation. Yes, who would want to volunteer? How will you interpret the beta coefficient, which is 0.0765? Sorry, before that, what is x? X என்னது இந்த எக்ஸாம்பிள்ல? ஆமா, இண்டிபெண்டன்ட் வேரியபிள். இந்த ஃபிகர்ல கேன் யூ see ஏதாவது இன்ஃபர்மேஷன் கொடுத்திருக்காங்களா? வாட் இஸ் யுவர் x? Yeah, you can see your x-axis label. X-axis la enna எழுதிருக்கு? Hand grip strength. So that is your independent variable. Okay. So now can you interpret what is 0.0765? Good, regression coefficient. Anna, how do you interpret that value? So I told you unit change in age. Age இல்லையே இங்க. Okay, hand grip strength measured in kilograms. So for every increase in kilogram, that is hand grip strength, as it increases by 1 kilogram, then y என்றது hand grip strength measured by another indicator. Okay, so increase again, that is also in kg. So how will you interpret this? For every unit increase in this measurement, your dependent variable increases by 0.0765. Okay, fine. So same way you have given it for female also. So let's say you want to present it in the form of a table. So what you should have is, you should have, so if idu vandute you will be able to do if you are doing a simple linear regression, because you will have only one variable. So scatter plot kudutittu that regression equation also you can put it there. You can also mention r square value in the plot itself. Okay, if you are having a multiple linear regression, which means you will have more than one independent variable. So ellathukku scatter plot podunnu avasiyam illa. Instead you can make use of a table. So here in the table you can mention what are the independent variables that you have, and for every independent variable you can get beta and standard error of beta from your SPSS output. So beta ku oru column, standard error of beta ku oru column, and then corresponding value. So this is how you present the results of your multiple linear regression. Okay, and here also inge edu solvinga for goodness of it? Multiple linear regression ku? Yes, adjusted r square, not the simple r square. Okay, okay, so any questions? Can we move to the hands on? Good question. Idhula eppadi beta coefficient interpret பண்ணுவீங்க? Okay, so here ஒரு beta coefficient you will have for one independent variable, right? So let's say here you want to interpret the beta coefficient for intermediate science. Okay, so here inge vandu final year students oda success rate is actually the dependent variable. Okay, and here நம்ம எடுத்துக்கிற independent variable, let's say it is intermediate science. So adoda beta coefficient is 5.47. so compared to, so அதே மாதிரி intermediate science ன்றதுக்கு you will have different numbers like reference, right? So 1 2 3 அப்படின்னு சொல்லிட்டு நீங்க மென்ஷன் பண்ணிருப்பீங்க. So maybe this is a little bit difficult example for you to interpret. We will go and see in our example when we do our hands on, we will do a multiple regression where you have all continuous variables, so it will be easy for you to interpret. Okay, because I have not showed you the exact question here. What is the exact dependent variable, what is mentioned here in a units la measure பண்ணிருக்காங்கன்றது information is not here. So let's do the correct interpretation in the example that we have in hands on. Set. Okay, so this particular data set has been taken from a book called as Fundamentals of Biostatistics by Bernard Rosner. It is a very good book which can be of great help to you because it has a lot of medical examples and all the concepts are explained clearly in a very simple language. So you can check out this book if you're interested. So the study is called as FEV study. So here they are looking at pulmonary diseased forced expiratory volume, that is what is FEV, in an index of pulmonary function that measures the volume of air expelled after 1 second of constant effort. So the data set of FEV study contains determinations of FEV in 1980 on 654 children. So that is the sample size here. Children ages 3 through 19 who are seen in the childhood respiratory disease study in Eastern Boston. So these data are part of a longitudinal study to follow the change in pulmonary function over time in children. So this is a study from which our data set we have got. So we have FEV for 654 children and then we will have other independent variables. So these are the list of variables that we have. So there is the first column, it is ID number. The second one is age measured in years. Then the third one is FEV measured in liters. Next variable is height measured in inches. And then the last two variables are sex and smoking status. So they both are categorical variable. With sex, 0 means female, 1 means male. And then for smoking status, 0 means non-current smoker, 1 means current smoker. So this is the data set which we have. Have you all received this data set? Can you open it? Have you imported it to SPSS? So the format is in XLS. So you should import it using XLS format. So quickly let me know if there is an issue in importing. Okay, you can raise your hands if you have completed importing this data to SPSS. Okay, நான் ஒரு டைம் பண்ணட்டுமா எப்படி இம்போர்ட் பண்ணணும்னு? ஃபைன். So go to file and then you have import data and the format is Excel because நம்ம data Excel formatல இருக்கு. So Excel click பண்ணுங்க. அதுக்கப்புறம் இந்த பேஜ்ல மேல login இருக்கு இல்லையா, அந்த பிளேஸ்ல you will have to go to the place where you have your data set. So mostly downloads la ungalku irukku nenikiren. So you can check your downloads and then you will find this data set called FEV study. Click that. Click பண்ணோனே அது கீழ அந்த ஃபைல் நேம்ல அப்பியர் ஆகும். அதுக்கப்புறம் click on OK. Done? Okay. Now here please check the first box. Read variable names from first row of data. ஏன்னா நம்ம Excel sheet open பண்ணி பாத்தீங்கன்னா first row it will have variable names. Okay, so first check box வந்து tick ஆயிருக்கான்னு பாத்துக்கோங்க. And then you will be able to see a preview here. So இந்த previewலயும் உங்களுக்கு ப்ராப்பரா இருக்கான்னு பார்த்துட்டு then you can click on OK. Should I repeat? I don't have any response. Great. Okay. So let's click on OK. Fine. So once let's check if everything is correct in our variable view. Okay. So go to variable view and see ID numeric, age numeric, FEV, height, sex, smoke, type ellame numeric ah irukku. Okay. Then let's also check the measure. Scale variable illa nominal variable irukanu solittu. So which should be scale variable and which should be nominal here? Ellam correct ah iruka illa edha problem iruka inga? Age. Yes, age is actually numeric but ana anga nominal select aayirukku. So we will change it as scale. The last two adu vandu nominal da illaya. So we will leave it as it is. And then now to perform regression, go to analyze, go to regression. Analyze tab la regression ponga and in regression you will have linear. Okay. Done. Click on linear. So are you getting this dialog box, linear regression dialog box? Okay. So now it is asking you dependent variable enna, independent variable enna. So which is the dependent variable? FEV. So you can put it there. Select FEV, put it as dependent variable. First we will do simple linear regression. Okay. So we will have only one independent variable. So can we select height? Okay. So height independent variable podunga. After this go to statistics. Okay. So these are the options that we have in SPSS for statistics when we perform linear regression. So check the estimates and also check the 95% confidence intervals. And then you can check descriptive statistics because we have not seen descriptive so far. So check on descriptive statistics and then you can also check collinearity diagnostics. Then let's also try to see if the assumption is satisfied, that is autocorrelation assumption. That can be checked using Durbin-Watson. Okay, so click Durbin-Watson under residuals. Have you checked these things? And then click on OK. Continue. After that, go to plots. After continue, go to plots. Okay. In plots, we want under standardized residual plots, we want histogram and normal probability plot. Again to check our assumptions are satisfied or not. Okay. After checking those check boxes, click on continue. So, idra statistics and plots we have incorporated. Then we click on continue. Done? Okay. So now let's interpret what we have got in the output. So first you will have descriptive statistics. So in descriptive statistics, you will have what is the mean standard deviation for the variables that you have used in regression. both independent variable and dependent variable. Okay, so your independent variable, so descriptive statistics we got as the first output. Then we will see the next one is correlation. So regression panamode you will get correlation as well. So correlation between height and FEV is 0.868 and whether it is significant yes or no, adume inge we will get it. Okay, so is it significant? Which is the number that tells you if it is significant or not? Significant one-tailed irukalla. So anga you have FEV versus height. You have values, right? 0.00 na enna artham? It is less than 0.001, right? Which means it is statistically significant. Okay. So now we will see the next one. So in the place one it will tell you how many variables were included in your model. So it will tell what is the dependent variable and it will tell what are the list of independent variables. Here we had only one, which is height. Now we'll come to model summary. So model summary will give you R value, R square value, adjusted R square value and the corresponding standard error. Okay. So this is simple linear regression, right? So both R and adjusted R square can be used, but it is better to use R square for simple linear regression. So what it is? 0.754. It is the same as what we saw in our PPT as well, right? So now you know the interpretation of this as well. So 75% of the variability in FEV is explained by the variability of height. Good. So the last one is Durbin-Watson. So this Durbin-Watson score ranges from 0 to 4. Okay. 2 actually represents no autocorrelation. So 2 is what we want. Okay. But always we will not find we get exactly 2. Something close to 2 is good. So this is 1.6, right? So 1.6 is a little bit close to 2. So we see that this assumption is satisfied. Okay. So this is some ballpark number that we should have in our mind. So there is no hard and fast rule. 1 ku mela irukonu, 1.5 ku mela irukonu appdi illa, but somewhere close to 2. Okay. So the preference is 1.5 to 2.5 irundaduna, then we can be safe telling that this assumption is satisfied. We can say that there is no autocorrelation. Fine. Now let's come down. You will also have an ANOVA output. Even from ANOVA table, you can actually calculate your coefficient of determination, which is R square value. Okay. But namakku ipo thevilla because already we got it as an output. Now, the important output is this coefficients. So here, you will get coefficient for constant, right? And then you will have another coefficient for your independent variable. So this is what we saw in our scatter plot also, which is minus 5.433 and then 0.132. So we also saw the interpretation for this. Okay. So corresponding to the beta values, you will also have standard error. So whenever you write your tables, you saw, no? One column you will have beta and the next column you will have the corresponding standard errors. And then you will also have to see what is the significance level for every regression coefficient that you have. You don't have to interpret the significance for constant, but you can check the significance for your independent variable. Here it is again significant, right? It is lesser than 0.001. So since we checked on confidence interval, for the beta coefficient, you will also get a confidence interval. And at the end, we also get VIF, which is variance inflation factor. So what will this tell you? In the number edukku keela irundha nalladunu sonna 10. Okay, VIF 10 க்கு கீழ இருந்தா there is no multicollinearity. So inga it is less than 10, right? So there is no multicollinearity. So we can be safe that the assumptions are satisfied for our regression. Okay. So we got two plots. The first plot is the histogram for residuals of the regression. Okay, so that epsilon term is what we have in the x-axis now, the residuals, and the residuals ku histogram plot panna we are getting a histogram, and it will also give you a normal curve. Okay, so ipo in the assumption normality of errors assumptions satisfy agirka illaya? Satisfy agirku because it is showing a very good normal distribution, right? Then again this assumption is also satisfied. So another way to look at this normality is by this PP plot, okay, for the standardized residuals. So the curve should be actually lying on that diagonal line. Yes, most of it is lying on the diagonal line. So therefore, by this plot also we can say that the assumption of normality is satisfied. Okay, so now we will do quickly a multiple linear regression. So go to linear regression. What we have is, let's put age into independent variables. So now we have two independent variables, which is height and age. Then let everything be the same. Click on OK. Okay, so you will get descriptive statistics, you will get correlation. Same way here for the model, you see there are two independent variables, that is age and height. And then your R square value, see it is 0.766, slightly more than 0.754 which we have seen earlier. But what is your adjusted R square? For this particular regression, it is same. Your R square and adjusted R square is same. But here we are doing multiple linear regression, so always look at adjusted R square value. Okay, fine. So this means that this particular model where we have two independent variables is actually better fit. Yena last R square நம்ம என்ன பார்த்தோம் 0.754, but now percentage has increased. So this is a better model compared to the previous one. Okay, fine. So here again look at Durbin-Watson, it is 1.63, which means it is close to 2. So we see that this assumption of autocorrelation is also satisfied. Then let's come down to coefficients. See that now the coefficients have changed. Constant is now minus 4.610. Height 0 and age is 0.054. Okay. Now let's make the interpretation for this. So now we have multiple linear regression. How do we interpret the coefficient? That is, first let us interpret the coefficient for height, which is 0.110. Height is measured in inches. So for every unit increase in height, which means for every 1 inch increase in height, FEV in liters increases by 0.110 given other variable, that is age, is fixed. That is how you interpret, okay, for a particular age group. So given for a particular age group, for every unit increase in your height, how much your dependent variable is going to increase. After adjusting for age, how is your independent variable influencing the dependent variable? That is what this regression coefficient is going to tell you. So same way, can you make the interpretation for age? What is the coefficient for age? 0.054. Okay, so what is the interpretation for this 0.054? So age is measured in which unit? Years. Okay, so for every increase in year, FEV value, that is in liters, increases by 0.054. Is that all? Given that your height is fixed or it is kept constant. Okay, so this is how you interpret your regression coefficient when it comes to multiple linear regression. Fine. Okay, so do you have any questions? Okay, we'll also check the plots. So again, yes, you get a good normal distribution. And what about your PP plot? Again, it is lying on this diagonal line. So your fit is good. Fine. So all the assumptions are satisfied, and at the same time, you have got a good R square value as well. So this you can, okay, this is a good model, so you can take it for your manuscript. So this is how you see. So you have to do this multiple times. So I have just done it once. So first you will have to do a simple linear regression for every independent variable and see how is the regression coefficient changing, how is your model diagnostics, which is adjusted R square or R square, changing. And then accordingly you will have to, so this is a trial and error method. So modeling is not a single step. So you will have to do simple linear regression first and have certain variables in your multiple linear regression. Then you should remove certain variables and see. So you should have this focus that you should increase your adjusted R square. Okay, that is the ultimate focus. Keeping that, your assumptions are satisfied. So this is what you will have to look at when you do linear regression. Any questions?